Hello guys, in this video I would like to talk about my engine, my 3D engine for Amstrad CPC that I have created and showed in our demo Start Trip. And I'm gonna talk technically first and even discuss some things both algorithmically and maybe a bit of Z80 assembly and show parts of the code. Now this is a new project where I ported parts of the code from the original demo. I removed other parts like some tedious scripting that I didn't need, and I created just an interactive environment where I can now play. I can move the object around, I can go close, far, but I have to not go too far because if I hit the edges there might be bugs. You know, I can rotate around or put some automated rotation, even switch to the idealist line or change some palettes. And I'll show you more objects later. And even objects where some objects that couldn't make it into the demo, from simple ones to some more complex ones. And I have a complex one in a DSK with some experiment that I couldn't load here because there are bugs. It has so many points for the current version of the engine, which because of some optimization I have a max of 32 points and 32 polygons here, but this object could hit 64 and it was too slow to include anyway. And I couldn't include it in this interactive engine, but I found an old DSK where I was demonstrating, along with a lot of other early code, when I was just rotating 3D points and nothing else. Or I have a non-idealist version of the line and other weird experiments. So now to do that, I have collected some notes here. And I put bullet points and things I want to talk about because I have to try to keep in the subject and not go too far and not make this video run too long. Although there are so many points that it might still run long, but I'll try to describe the things I want to describe as good as succinct as possible. We'll see. So let's start. The core thing I want to describe, and hopefully the one I can easily, maybe the harder, no, it's not so hard, it's just, yeah, I need to visualize it to describe. And it's a common technique. It's a technique I'm using to avoid doing many rotation multiplication. So my engine still has to do few multiplication and divisions, and if you can reduce, it's better. They are very. So I found some binary multiplication and division that are still optimized for Z8. So I didn't write my own. I found some on the internet. But there was still an attempt to kinda reduce or doing divisions, for example, in smaller bit sizes when possible, or pre-store certain things. I calculate that I can reuse. So there are all kinds of tricks to avoid, but I have to do multiplication divisions at some point. But my whole engine, I haven't read that. I just operate on 8-bit or 16-bit. With 8-bit and 16-bit values. Usually. So I never went for, okay, let's create a 24-bit or 32-bit generic math library or even floating point. I knew that I'm doing something for the Z80, and I knew I have to manage to do 3D, even if the lower the precision it is, the harder it is to get something. But I got something relatively stable, surprising. And I also used a technique to do rotate after I construct my rotation matrix, my 3x3 rotation matrix. I didn't have to do any moves with any vertex point to get. I just had to regenerate something that needed few more 16-bit additions from the 3x3 matrix, and I needed to store my points in a regular grid. And I'm gonna explain. And I heard that this was a technique commonly used on Atari ST demos, but probably it's used on Amiga and other demos, even Commodore 64. Because it's not extraordinary. It was, if you understand it, it was obvious. Like, wow, I can rotate points in a regular grid with 0 multiplications. Except the initial multiplication, you need to create a 3x3 rotation matrix once per frame. Okay, and to do that, I choose an 8-bit signed 8-bit signed lookup table. I started from that. So, and I just had my signed data. I didn't generate it. It goes from 0 to 255. Probably 255, if it was unsigned chart, it would be the highest point. It goes from the center and goes up. Now a sign will go up. Now this, if you convert this to sign, it's gonna go to the negatives, and 255. This is weird. I think I'm getting this one, and then I'm generating the actual values for the sign. Okay, I start from this one. This is unsigned chart, and then I have an initializer that converts it to this. And now normally it would be minus 128 to 127, but I think I clamp it a bit to 127. So here is the thing. Now I have some things open here. Normally the thing with 3D rotations, let me see which one I have all kinds of stuff. You would have rotation over x over y over z. You would multiply the 3x3 matrices together, and you would get some kind of combination that might have a cosine A by cosine B, cosine sine sine. No, theta is the angle here. No, I don't know. There are okay. You will get some 3x3 matrix where you multiply a lot of the sine with the cosine. Now my sine 8-bit. Oh, and this is fixed point, by the way. So minus 127 would be minus 1.0127. So when I multiply A by B, and these are fixed point, it's gonna be A by B and then shift back by 7. So at the end, if you multiply sine by sine themselves, you will still get something inside this range. Because I consider it fixed point, and I think I have a. Let me see the math stuff I have. So I'm going a bit into the weeds here, but I have a specialized mul signed 8x8 and SHR7. So I've gotten from the internet. These are unrolled, and they are they're doing it bit by bit 8 times. Or I have division 16 by 16 and it's unrolled 16 times to make them as fast as possible. And I got them from the internet, and then I might manipulated some stuff. So maybe I had an unsigned mul or div, and I made them sign by checking the 7-bit, keeping the sign, and then at the end, after the result, and I would make the numbers positive and do the positive multiplication. So it's a function I found on the internet, efficient functions for that. But maybe there are other ways to multiply and divide with logarithmic lookup tables and other. There are things that I haven't said. I went there and I did that. And if I needed something specialized, I wrote it myself on top of the original. So I made a specialized thing. Well, I shift by 7. I want to say that generally I try to shift by 8. Because if you are in assembly, if you have a result on HL register, you can just say LDA, AH, and it's like you shifted the HL by 8 and got this. But if you had the result, even on 8-bit, if you had an A result and you have to shift by 7, you would have to say shift right logical A 7 times. And this is taking, every one of this is taking 2 knob cycles, if I from what I remember. So it's gonna take 14 rounds. It's not good. There is nothing like comma 7 or something on Z80. So I made an attempt, even if it has to be 7 bits. I made an attempt to kinda work it out like an 8-bit shift. I still do LDA, H, but I do an extra add HL by HL, which is like shift left. I add the HL result. It's like I shifted that one more time. It's like I said A plus B shift 1, so that I can finally do shift 8. So that I avoid the 7 SR error. So I kind of do that stuff, and I do that on other places. So even if sometimes I don't have the exact 8-bit representation for fixed, I have 7-bit because it had to be signed, or maybe I do something like that in the projection, where much later in the projection I multiply by a number. I choose 256, and in the projection I do something. I don't even multiply or move, or maybe I do. We will see that later. So I will be doing some triggering at some places, because Z8, if you do fixed point with any other, unless you do some 4 bits fixed points, okay, maybe you can do 4 shift. It's not as bad. Or maybe you could use some lookup table. But I've chosen to do tricks like that, so that I am at 7-bit fixed point, in a sense, but I don't need to do 7 shifts. Okay. So to explain that, first I want to talk about so I create the matrix in the similar way that you could create the 3x3, the rotation matrix only, which will involve multiplying cosines by sines, which are all lookup table values I get in 8-bit, and sometimes sine by cosine, even 3 numbers together. So it is a bit involved, but we can even see, I'm having this blank page so that it's not distracting when I show code. In the 3D math, I even have it here. Here it is. And you see, I wrote manual assembly and tried to optimize as much as I could by keeping some registers and so on. And you see on the comments, it's a bit, I got that from a C code, from my various 3D engines in C, C++, from PC Demos in Project or Game Park 32 or wherever. And okay, previously Let me see something. It's not very important. Okay, I think the update rot trick is called before I calc rot matrix, because we are gonna read sine xr, sine x rotation, y rotation, z rotation, sine and cos of that. I use the base sine, of course, and I read these values once. Add 64. Okay, because that is from 0 to 255. 64 is like 90 degrees. It will loops around 256, but 90 degrees would be the equivalent of 64. That's to get the cosine also. And I end up reading these ones and just storing them in those variables so that I later can retrieve them whenever I want. Because I guess, yeah, I called the update row trick here before I start. I could have had the base sign in HL and read it directly, but then I'm very low on registers, so it was easier to handle it like that without having to keep the base sign. And I'm doing the regular read cos YR, cos ZR, multiply, get a result. I have an idea on math that this multiplies is affecting certain register, but it might not affect certain. I think B is not affected, and B and C. So it was very tedious to do this, but it was the first thing I did. And sometimes I noticed that this pattern sin xr by sin yr by cos zr might be repeating in some other calculations, like here you have cos A sin B cos sin cos C gamma, and you have it repeated here. There are some things that repeat, there are some things that don't repeat. There are more things that repeat here. Or maybe no, there's a cos, there's a sin. So okay, I kinda tried to optimize that a bit. Although it didn't matter much. It's little optimized. Like some things could be kept in reason. So I use the IX low here. So that I don't have, and actually that's good. Else I would have to recalculate, call the multiplication again for the other part that might be finding. So there was some attempt to reuse things, but it might not be the best configuration for reuse, but there was an attempt. So and I end up storing everything in the rotmat. I have the rotmat, rotation matrix, rotmat 0, plus 1, plus 2, plus 8, and that's it. Yeah, probably, yeah, I have the rotmat here. I have those that I store, okay. Maybe I shouldn't go too slow with that stuff. And I wanted to show something. I realized at some point, I always use this one, which has a lot of modes to construct it. It's more. I realize you can make rot matrices for x and y. You can make rot matrices for x, and a lot of the if z is 0, then the sign of z would be 0, the cosine would be 1. So a lot of the things are simplified. And you could make, I could have made cos rot matrix only x, only y, only z, and do a lot of stuff. So I have this. I mostly don't use it. I realize with x and y you could rotate some object and still look like, oh, they are revolving around themselves in complex ways. And I could have optimized more. When they are the star trip letters, when they come, they rotate only over one axis. I could even have a cos calc rot matrix x and use them. But for the letters, I did use this one at the time. Initially, I was using that one, and then I realized, whoa, man. Because this matrix doesn't have to just be calculated once per frame, but once per object. If your next object, if you have many objects in the scene, and the next object has a different rotation, you have to call it again to get another matrix to use it on that object. So I guess I can do we are still working on some new version of the demo, maybe a final version, but I don't know when and how we're gonna release it. But it doesn't matter for me. It's mostly I always look at the code and do improvements. Anyway, so we calculate the matrix, and maybe I should move faster here. And that's the only time I have to do multiplication. That can be kind of costly. But once per frame or per object, that matters. It's not as costly as I thought. But you could always pre-calculate even that. You could always do other kinds of big lookup tables for rotated position. But okay, I did it like this. I calculate the matrix in real time. It was a pain to do. Now, normally, sometimes the full 4x4 matrix is the 3x3 matrix and the translation. And this usually is 1. But there is a theory with a homogeneous, but we don't need it. But I don't do that. I only do the 3x3, and the translation are separate additions and the projection. I only work with 3x3 matrices. And normally, you would have to do this thing. You would have for every individual point. So if you have an object with 10 points, you would have to multiply the matrix with the x, y, z. So you would have to do you would have to do 9 more multiplications, unless some of these terms were 0 or 1 and they weren't arbitrary numbers. So you could reduce that a bit. So it would be a pain to do. I think the tools I have is 24 points or maybe 32. Maybe I reached 32. Maybe 24 and 32 polygons. So I would be doing way more multiplication. It would be way more slower if I did that, which I don't. That's the magic. And now I'm gonna show you. Now there are things here that, okay, this is a good thing. I for some reason did my own. I work in grid points. The original axis, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. If you rotate the object, you have a rotated version of the axis. And the trick goes, first of all, let's see what I have here. Okay, I have it here. I'll show you. The trick goes, and you can even, it's described in various places. If you take, after you calculate your matrix, from the rotation matrix, the columns, you really have the rotated. These are not just that. These are the rotated, reoriented matrix. Okay. But if your axis were 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, you take the rotated version of them. And here's the thing. In this small grid, here is point 0, here is point 1, 0, 0, 0, 0, 1. If you go, it's point 1, point 2 on x, minus 1. It's just minus 1 and 1. It's hard to say. It's not this. Okay, it's hard. This is 0, minus 1, 1 on x. On y, 0, minus 1, 1. Okay, I think my point there is wrong. This should go up there. It's very hard. I realized I was trying to take screenshot from the engine and trying to draw on top to just visualize what I mean. So if you have a point in your mesh that is sitting on here, the rotated axis would point to the point here, the x-rotated axis. And here's the tree. Let's see if I have something else from there. It shows there. That's a part of the theory that it wasn't very obvious in the beginning. We always used to generate this matrix and just do the multiplication. But the whole trick is based on that. Maybe we don't need anything. The whole trick is based that if I store my points in a regular grid, here is the bulk of the trick. If I don't say, or even if it goes integer, I don't say, okay, unless you have a big grid, but I say, okay, I say 001 minus 101 010 110. Then the original points before the rotation in object space. If I rotate those and get new values, I don't know, like A is, it's gonna be A, it's not gonna be 00 because they are rotated as this. Then it's kinda easy from that stuff, depending on the indices, to find where your new points are sitting. Because here, if I have a cube where there is this point, here is that point. I could move on x vector and then add y vector. And if you're okay, maybe I'll show you. These are my objects. No, so now it's hard to explain. Okay, this is how I define the point. Now, you might say these are coordinates. These are just coordinates, minus 1, 1. But it's also index points. You can think it like that. At the end, it's also coordinates, but in a regular grid. There is no way. I cannot put 0.5. And also, if you see all the points, they are defined 0, 1, 2, 3, minus 1, minus 2, minus 3. I think I can do minus 4. I'll tell you why. So all the points are, it seems like the smallest integers possible from the center on positive and negative. They are also coordinated, but they are thought as index points. Why? Because here is the gist. If I rotated my matrix and I found the new rotated vectors for 0, 1, 0, 0, 0, 1, 0 for the unit axis, and I define my point as is the point at index 1, 2, 3. At the rotated axis x, the point at 1. Now this is hard. This visualization. I move 1, and then I add x. This is 0. I add x tonus 1. I add y tonus 2. Add 16-bit additions. They are 16-bit additions now because the sine and cosines are from minus 1 to 1, but they are fully fitting the 255. So I convert those axes to 16-bit values so that I'm now on a 16-bit fixed point space, which is still a 8 bits integer and 8 bits in some sense fractional, or maybe it's 7 bits, 9 and 7 bits. And see, you move from that point on the transform x, y, z, you add the y coordinate of the rotated axis twice, and then you add it 3, and it goes somewhere inside the cube. And you have the rotated point at index 1, 2, 3. Also, the indices can be negative. Now, this example might not be very good because because of visibility, since I decided, okay, I'm gonna put this as 0 and it goes positive, positive, positive. But normally I have something more like that, where this object is 0 and there are more points outside. I couldn't put more points because it was such a mess, such a cloud of points, that unless I had some interactive visualization, it would be hard to show. So this is an indication. And now here is but do you want to add main? What if you have a point that is at 444 or something? Do you have to add many times? And that is another, it depends on what you do, of course. That is another thing I did. There is an extra step now. Here, how to explain. Create the 3x3 matrix. Okay, you don't have to mull with it. All your mesh vertices are thought as sitting on a regular grid. And now I have to do this step to create some extra lookup table data, where suppose this is 0. Now again, the real code is going from the center of a cube, grid points. It's even a center that goes from -4 to 1, 0, 1, 2, 3, 4. It goes like that. It goes vertically. And it goes also on the Z. I don't create every point of the cube because that would be too many 16-bit additions. By the way, again, I start from 8-bit signs, I rotate, I get an 8-bit result, but then I just convert it to 16-bit at this point by extending the 8-bit number to 16-bit number, and I think I have some functions there, or I do it by hand within line code. Because on the next step, I'm going to do things like, add HL, comma, HL, add HL. Because the points at 1, -1 might be fit, but the points at 2, 3, 4 could be close to 512, close to positive 256, positive 384, positive 512, negative. So they have to be 16-bit, which is good because it's very helpful for the next step. So I only calculate gradual point on the horizontal axis, on the x-axis, on the y-axis, on the z, which is one unit vector, 2 unit vector, 3 unit vector, 1, 2, 3, and it could go also minus if that point goes on the center. Now this is a bad thing because I couldn't. That's the important step, and maybe I could show something. Maybe I'm doing that. I'm doing the calc road matrix there. Those are irrelevant. They have to do with the scripting. I rotate some values from the object and then I have to copy in a central place to use them for the matrix. I have a flag to decide to use the full matrix or the XY anyway. And then the important thing is the update road axis. This is the part that constructs those intermediate points. Let's see, because maybe I have it there. Is it on 3D math, 3D funcs? Oh, okay. So it is here. I had other kinds of functions, update, road tag. I might not use that, we'll see. And I'm not gonna go much on the assembly, except I'm reading the road. You see, I'm reading road mat plus 3 plus 6. Forget about this string. This is some kind of trick again. And then I'm reading. Ah yeah, no, see that one. Forget about it. See that one. Road plus 3 6 1 4 7. So basically in the matrix I'm getting road mat plus 3 plus. I'm getting vertically the columns. And I'm getting axis plus 2 plus 4, axis x, y, z, which are some storage. Okay, this is just, okay, this is not doing the thing yet. Sorry, this is not doing. This is just reading those vertical, those matrix values from the column and store them horizontally on the axis x, y, z. So I basically have 3 vectors with x, y, z. I'm getting the oriented vectors. And then I'm doing something else, which is to do additions to create the grid. Yeah, I'm getting a bit slow with this one. Sorry about that. It's gonna be like that. I'm doing that later. I'm doing this on Draw Object 3D, I guess. Oh yeah, I'm doing a lot of this thing. I'm not gonna explain everything. And I'm generating those axes with the 4 points. I'm doing some hacks because I'm not starting from point 0 and adding. Because I know the point 0. I don't know. There was a reason I did everything. Ignore. Technically, I'm generating those in between grid axes. Why? It's gonna be because now I have created lookup tables. Okay, maybe I will be more. I have created lookup tables of all these intermediate points where, if I want to say, go on my point is at 3 1. What the hell is with the color? This is the index of my point. I would go, okay. What? 0 1 2 3. I could go here, get the x y z of this place, add it to the x y z of this place of this point on the vertical axis. It will land me here, and grab the x y z of the z axis and add it all together. It will land me somewhere inside in the actual point that matches here, the rotated, the oriented point on the index 311. So that's the idea. And the thing is, the unit axis we are getting is only this. Only this, and this. But in an extra step, if our cube is 3 by 3, 4 by 4, whatever, because most objects can sit in so small values, most retro 3D objects, the very early 3D, you can do 1 addition, 2 addition, 3 addition over x, y, z. So it's like 9 additions, and it's just add HL, HL, add, which is pretty good, pretty okay performance wise. And you can easily have some pre-calculated new position. You have to do it every rotation, which then you will look up and avoid all multiplications. So how much of an improvement is? Maybe for a few points it's a bit too much. Maybe if you want to do some dot records. And I even say here that, okay, actually in the demo, my full thing is from -4 to 4. So it's 8 point. Actually, it's 9 because it's 0, but I think I skipped 0. But no, I have on the outside. Maybe it's okay. Maybe it's that. But then you have to do it by, so it gets a bit more. I'm doing 16-bit DAS, 18 add, and things. But it's not just okay. It's still taking me some space. I do it separately for every axis. It's still taking some time. It could have been done faster. Because and I try to optimize the Z8 as much as I could, but it gets a bit. I even unrolled it. However, because there are not enough register, and I need X, Y, Z of axis X on that index 1, axis Y on index 2, and axis. And the rotated point will come by, I guess, 9 lookups and 6 adds instead of 9 moles, or maybe a bit less moles. And also many lookups from the matrix, and so that was the optimization idea I had. And maybe there are better ways to do it than the way I did. This is a very fundamental thing of my engine right now, and I have a lot of add HLDBC and extender edge report. It's still kind of. I have profiled all of this, by the way. The compiler, you can put a breakpoint, put that to 0, run it, put another breakpoint, and find. I have profiled a lot of that stuff, and they are doing okay. It's not that bad. It could be better. The preliminary stuff, like okay, create the matrix, create the grid, will take 400 knob cycles, 1000, 2000. Collectively, they will be still inside one VBL, and then the majority, the polygon rendering, is gonna take much more. Like you could be, for a cube, you could be spending 10,000 knob cycles on the preliminary steps and rotation, projection, and maybe 35 knobs for edge working. So okay, there are some knob cycles wasted, but the 3D math, I end up with much fewer, and it can be improved. Okay, I don't know. I don't say it's fast or not, because maybe I wrote some stuff. Maybe some stuff can be written much better. Maybe you can make. Okay, I have this idea that you can write the same way you write compiled sprite. I'm gonna write it because it's the same way one can write compiled sprite unrolled codes tailored to the sprite. That's fine. The same way one could write, which I didn't, more specialized unrolled code for these rotations, like an object will only use -1. We have symmetry. So you could optimize, you could do sprite.records with very specialized tool to write, instead of my general way that loops through every point, grabs the indices, and writes all this. I'm doing this a bit later, for example. This is the generation of the grid, and later, forget about it. It might be the rotate.object. I get the grid axis. I have the grid axis stored. And also, I might want to show you something. Let me see. So the grid axes are sitting at these addresses, 0A0B0. Okay. I might want to show you something. Okay, so, sorry, no, 0A. I know that is 0A. 0A. 0A, 0B, 0C. Now, close that. Rotate it in some way. Now it's rotated. 0A also. There are many points here. I don't know. Okay, it's not easy to show you because I might do some tricks where I also use 0A later for other. You don't have so many numbers. Normally you have less. Oh no, you have. Sorry. Because it's storing X, Y, Z. It's storing grid access store for X axis. X0, X1, X2. And also you have X minus 1, X minus 2 and so on. And it will store 6 bytes per point. 16-bit for X, Y, Z. Because it's gonna store, this point here, this point here, this point here, all the coordinates, X, Y, Z. Because it's not aligned it's rotated, so now it's not 1, 0, 0, 2, 0, 0. It's values for all three axes. You have 3 by 3, 9. So it really stores. You see, at 0, at the origin, 0, 0, 0, 0, 0. Then some other rotate values, then some further values. And if you add them, it might go 4 points. But at 0A, F0, on the negatives, you have the negative value. I did again the same trick that I don't want to get the index at the 4 in the minus 4. I didn't want all my indices to be here and the 0 index to be somewhere in the middle. I wanted my 0 to be there and the negative to be there, so that I get a byte in Z80. I get the index as a byte, have the high value 0A and the index value, whether positive or negative. So I do such tricks. So this is the positive points on this axis, the negative. Here is the y-axis, the positive rotated values, the negative. And those are my lookup tables for the whole thing. Okay. Yeah, this is getting a bit long and I have to... This is the basic idea. This is the fundamental idea where I started everything. And really, to make polygons, I have to do a lot of other ideas. But most of the other ideas are not so... They are more common stuff. But this was the best. And I'm gonna say, someone told me that I'm gonna show you two things. Maybe Atari Equinox. Maybe that one will have it. Someone told me this trick to avoid multiplications per vertex, but all your objects have to sit on a regular grid. And most of the retro objects I created sit nicely on regular. That it was very common on the Atari ST demo, probably on the Amiga, probably on many other places. And a very common thing was to even see, let's see if I can find it. Now this could also be done with that, I don't know, but a very common thing, I need to find that, yeah. That's a very common thing I see in many Atari demos. Oh, it has noise though, it has delay. A very common thing is to see dot cubes. I see this very often. And if you have a dot cube, instead of doing what I do with the lookup, you can take the dot and add walk, pop the values, add one down, walk, and get all these points. If you made a dot record with a 4x4x4 dot cube, 5x5x5 dot cube, and so on, you could take the original vectors. You don't even need to do this lookup table I do. And you could optimize in various ways, maybe even unroll the things in some ways. And when it's like the rotozoom, when you finish here, you go up and you add one to the vertical, and you do the same on the second plane, on the third plane on Z, and so on. So you could walk gradually by doing one 16-bit addition every time to get the point. Actually, you do three to go from point one to point, because you add x, y, z every time. But you do one addition to go to the next point. You don't do multiple addition. You don't have a lookup table for the. So if you were doing some regular grid thing, you could even do it like that. And maybe with symmetric object you could do various tricks. Maybe with other things you could do all kinds of stuff. That's the one thing. And I see more Atari demos that were doing this kind. Even this new Atari demo. The first effect is again is this dot, but it has delayed dots. So you could do such regular grids. So you can write specialized and not generic with object indices to do the exact thing like this. And maybe you can do some variations with. Now, on Eder, here's a dot record screen. Sorry, I closed the mute. And I noticed, I don't know if they'd use this trick. Maybe they use another trick. I don't claim that they use this trick, but I always notice that the tag object, I'm gonna put it, many times it seems like the points are aligned, are sitting in a regular grid. It seems very squarey from some sides. Like many points are sitting while they should be more circular. And it's just my assumption every time I see that it might be using a similar trick. That's what I have to say. Also, if I wanted more complex object, I could have done the final thing. I'm doing this grid now, and those points from the other. I could have done 16 points, 20, and I even calculated that I store 6 bytes per point on this 256 bytes storage, positive and negative. I must have calculated that if you do 20 by 60, I have plus minus 21 by. I think I can store positive and negative 42 points. So I could have, but there's also the origin point. The origin point is in, maybe. Anyway, I could roughly have a grid of 42 points horizontally on X, Y, Z. I would have to do much more work in the initial step to generate this with much more point, going further. But I could have something that is way more detailed with more precision, so that I can load some more interesting object that doesn't have to be as much aligned in a very crude grid. It would still be aligned in a grid, but I would make a longer grid that I would string the coordinates, because I can take the initial axis and then I can do adds and shift to shrink them. And you can also make scaling if you want to scale the axis on X more than the Y and Z, which I do on the laser, by the way, because I wanted to make thin lasers. So I generated not the initial axis. I generated the initial axis. I don't have them there. And you could scale them and even do scaling effects, like a wobbly 3D or something. So there is quite potential in this system, and that's the fundamental. And you end up, because of many additions of values that are the highest signed 8 bits, you will end up with 16-bit values, 16-bit fixed point. You can think it of the fixed point, you can think it as any, you end up with values. And that's the first part. That was the important part. That it took me quite a while to explain. And maybe I will try to get faster with the rest. We'll see. So the next thing is that I wanted to do. You can make 3D without projection. It would look less exciting. I wanted to do the projection. I wanted to do the full thing. I don't do much tricks. I just do the regular division. So it's a bit costly. I wanna say though, in the I don't have, this is the code of the interactive. For the 3D stars, now this is the interactive engine, but this one is just assembly. This was let me see. This is the code of the demo. I would have some lookup tables from 6,000 to under 8,000. A bit restricted for some things related with the star division for the projection. Because at that point, I had 64 stars, I think. And, okay, if you do some projection division for 4.824, okay, I guess there are some that are... Okay, but if you have just the 3D star as a very simple object and it already dies because of the division, it didn't die exactly. I was wasting a bit over 1 VBL just for the stars before I did this lookup table. So it's only on the stars that I did a kind of smaller lookup table, and I restricted the position of the stars to only sit on certain places, so that the projection division, the table would be smaller, because I didn't have much memory for huge lookup tables for the divisions. And I was from over 1 VBL to something like I don't know, 40% of the VBL for the star. It should be less because it's just 64 stars, so maybe something on my Z80 assembly. So I had challenges like that, but for the points, I just go and do division. However, I still do some tricks. Now, when you do a projection, I need to remember that I did a bit of an extra trick. You multiply by some value, whatever value, and you divide by Z to get the screen mix. And obviously I do that from the screen Y to but even on a PC code, I tend to use 128, 64 or something. Because I can do it with left shift and avoid the multiplication. And I think now I need to see. I might not have done this. I might have. This is a 16-bit value. But also this is a 16-bit value, because that's the Z. That's the rotated Z. I might have done this. I scrapped this and I did X tonus divided by Z tonus. I reduced the precision a bit. I might have done this if I remember. Because this one will be like getting, this one would be another, if Z tonus is HL, it would be another LD comma h and then divide HL. No, X tonus by A. Maybe X tonus is on BC or something. And here is the thing. I have, maybe I should be fast, but I don't know. I have different divide. I have a division of signed 8-bit by 16. And the result, I still give the result to HL for some reason. I have a division signed 16-bit by signed 8-bit, and I have a 16. Is it that the result is on... I have some specialized things with comments. I can't explain much. A typical signed 16 by divides HL by A, result in A. And I store an extra sign because it's signed, so that I could convert from 8-bit to 16-bit for something else. I have very specialized stuff here. I have the full signed 16 by unsigned 16. If I needed the signed by signed, I could do it. Generally, if I divide by Z, because I know it's positive, I use it. I might be using parts of it on this, and I ended up, maybe we can see something a little bit, and we can see by, I did some kind of stats here, and I have of how many the occurrence running the demo for a long or pausing in a certain frame and counting how many division of this if its type is happening, so that I see if I could optimize it. And here's the thing, much later I did a mixed div signed anyway, where here's the thing, if I divide by 5, I'm gonna get a result grade overflows over over 1 byte. If I get something like that by 250 by 100, I will get something close to Deca. Fits inside 1 byte. My whole plan at the time was to have screen coordinates. I say various divisions. The screen coordinates is minus 128 to 127 pixel coordinate space. Maybe it's 127. Well, it doesn't matter. It has to be. It has to fit inside byte. And my screen, I made the screen 256 by 250. It was 320 by 200 in mode 1, and I just used some CRTC contraction and expansion. Contraction on X and expansion on Y, and it still fits exactly 16K. So that I have something that somehow the coordinates are perfect for signed 8-bit. That's how I started. That's why I pick up this screen mode. And initially, when I have some object on this, I was afraid that I would fall in this case. But then I thought, if my object positions make sense, points, if you don't have your object very close to the screen or outside clipping, will always fall inside 8-bit. So I did this assumption that maybe it's okay to have (16-bit) maybe a division of some of this division, I don't know which one. With the result on A. It is okay. So I can use the specialized division that takes quite less cycles than the full 16-bit. And because unless I zoomed my object very closely, unless I decided to be like, yeah, you know what? Again. I'm such an idiot. I'm gonna zoom very close. Unless I decided to do that. Or even do. I'm gonna put the object there outside. Very far away. I didn't need to divide, basically. Because it's gonna be, the result will be, if my script of the object position and rotation and so on has the points inside, I will only need to fit inside one byte. But I think later I have to do both division, and the reason was a lot of things changed. I have to do also this division with 16-bit HL BC by D, which is more costly. Because I wanted to be able to if the points went too far, to still not lose to make the proper division and store them in 16 bits. Because later, much later in the demo, I decided that, you know what? I need to remove. You know what? I need to do clipping. At least with the bottom. Now, I haven't completed. That's another secret. In my demo, I did clipping, and I do store points left and right. Here is a bug. Here are bugs with the erasing. Now, it's only here correct. Here it squeezes, it clamps the points for the moment. Because I have to handle them different. Here it clamps the point. It's very bad. It's very bad. I know. Here it works correctly. Here it's gonna clamp so that at least it doesn't create problems. And in all my demo, the objects are always clamping here. Because I decided I'm supposed to add clamping. And because I decided to add clamping, I realized that I will need in some cases to do the full division. And I think I optimized this by using this division, which it will decide based on the value of E. It will decide if the result will be fitting or not. And I think how does it decide? If the high byte happens to be smaller than this, it might be inside, but it might be, it can be smaller or double of this. Okay, so I'm doing a simple comparison to decide if E compared to HL is much smaller. And even here, I'm not dividing by D. I'm setting D to 0. I'm dividing by D, but I'm not passing a DE that is higher than plus minus 128. Actually, the E is positive because it's a positive Z dividing. And I have this too. Maybe I'm using this for the edge walking. So you realize I started with realizing I just need to do the 8-bit division, 16-bit by 8-bit. And then I realized if I need to clipping, I need to do more. Initially, okay, if my object is inside, I don't need to use the slower full division. And then I decided I need clipping, and I had to change everything, and even the division, and not just the division, how I pass. It was a pain, and I haven't done clipping in all places. I haven't done clipping in all places because I started with the easier one, and if you have an edge, if you know that this is 200, here is 128, 127, you do 200 minus 127 and get something 60 something, 60, 70, whatever, 73. And I know I don't have to walk vertically as I'm adding, as I'm going from top to bottom, and I'm adding a fixed point. I don't have to walk there. I can reduce the total count and stop here. And I have an initial slope. But if it's like here, I have to calculate this count again. This is easy. But then I have to prematurely add values to find at this point what is my x coordinate at this point. I cannot start from this x point, it will be distorted. But here I can start with this x point, add fixed point calculation to walk on the edge of a polygon, and stop prematurely. While here I have to do it the other way. And the way the code was already complicated for some other reason. I was calculating the division later, or I have a cache array for reused divisions. I have some other ways. So it was harder to do this. And horizontally I have to do some things in others. So I didn't. I just, for the demo, I did the clipping in the bottom, which was perfect for, okay, spaceship comes from below, enters the scene, object from below, objects come in the center and fall down. It was perfect. So I have an engine with 1/4 of the clipping. However, I store in 16-bit both horizontal and vertical position, and I use the extra byte to know if I have to do some extra stuff for the clipping, even the sorting of points, even some other, even the erase areas to know which are the previous areas. So I had to change all places in the code, which I haven't explained yet. I need to see if I can. So I can talk about the object data a bit. It's very simple and nice. Yes, the spaceship. I fitted the spaces both in indices. It's again indices. 0, 1, minus 2, minus 2, minus 1, 0. If you put them, you get the tiny space. I have the object. Initially, I have ob space 1. These are the addresses so that later, if I want to read the polygons, I will read there. I do plus 4, get the polygon index, get the labels and so on, and the materials. So I pass the point. They are bytes. Number of points, x, y, z, x, y, z. In this index, it's still coordinates in some sense, but it has this grid index logic that is I'm using. Now, I don't use lines in some objects because I didn't display wireframe for everything. But it's the same. So here I use lines, again, number of lines, and now those are the vertex indices, not the indices, the coordinate indices, the like 0 to 1, 1 to 2, it could be 0 to 7, and so on. Okay. So now those indices and the polygon indices are referring to those triplets of indices. And the polygons are nice. Number of polygons, 6. The cube has, here is the thing, the good thing that my engine does, it's not just triangles. I have a nice, an easy way to to have nigons. You can have quads because and that makes a lot of objects much faster because I don't have to handle individual triangles and walk through more edges and so on. So the cube, it always, every polygon starts number of edges 4 and indices 0, 1, 2, 3, number of edges 4, 1, 5, 6, 2 and so on. So if you go to the pyramid is a good one. The pyramid, maybe we can see it. I need to remove that. I have it somewhere. Remove it. Now the pyramid. Okay, this is the quad. I will show you something with the quad. This is more like a tripod, and this is the pyramid. Maybe let me rotate it myself. You see, it has triangles and it has a quad in its side. And the pyramid, 5 points. It is 5 points. Defined -2, -2, +2, +2. You see, -2, -2, +2. The center is 0, 1, 0 on top. Maybe I'll rotate it and keep it rotating. I have a wireframe, the pyramid lines. 1, 2, 3, 4, 5, 6, 8. And the polygon, you see 5 polygons. First polygon, it's a quad, 4 points. 3, 2, 1, 0. 3 points, 3 points, 3 points. Triangles. And then the material, 5 material. These are the colors. The 4 colors. 1, 2, 3, 2, 3. That match to the polygons. So I have variable edge polygons, and that's very useful because let me see if I can find this object. I have one object that I never saw with polygon. I saw only with wireframes. I will skip it. This is the one. As you see, it has quads on the side. It has an octagon. It's the drum. In the demo, I only saw the wireframe version. I never saw the polygon version. And that's the drum. And you see the polygons, 10 polygons. There are 2 octagons, 8 points. 0, 1, 2, 3, 4, 5, 6, 15. Nice. And here is the thing. Let's take a screenshot. If I was to use only triangles, which you could make a triangle lens, but it was a good idea to use, especially for a lot of objects that use quads. If I was going to use triangles, okay, now, oh god, now this is one. This has 8 edges. There must be a tool that lets me. Yeah, if I was going to use triangles, it would be like triangle, triangle, and maybe, I don't know. It could be like that, it could be from there. I don't know the optimal topology, but if I was going to use triangles. And I would have 6 triangles, but not only that. The there is a lot of work happening on the polygon renderer when you have to walk on edges, because you have to do a division per edge to find some fixed point step, and then move vertically and add the horizontal step and walk here, store the leftmost points in a table, and walk on the right side and store on another table the rightmost value, so that you can horizontally fill this thing, and then you are gonna fill it in one pass. So the Nikon are great, because if I worked only with triangles, I would have to walk here, 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 here. I would have to walk in much more edges. It would be slower, the cubes would be slower, everything that uses quad would be slower. And then I would have to individually do more divisions and walk individually in scan lines here, and here, and here, and here. So the Nigons was a great idea. And that was an idea I did in the past. I discussed with a friend that you can walk left, right edges and store things in an array for leftmost point and rightmost point, and fill longer horizontal lines. Now the thing is, this works great for flat polygon. If you are going to create Gouraud interpolation or texture interpolation, there are many problems, because the interpolation step becomes not constant. It's only on triangles. If I'm gonna display that with Gouraud shading, I will switch to triangles, for example. In the future, if I implement Gouraud shading, because there are some mathematical reasons that on triangles the interpolation step is constant every scan line, but in non-triangles it varies for some reasons. And there might be an easy mathematical proof for that. Like, get the interpolation equation on edge 1, edge 2, and edge 3, and things will cancel each other. That's what I expect if I try. But when you have more than 3, it stops being a linear plane in some way. There are various issues. But if you know you are gonna fill one single color, this is really, really, really good for a lot of this object. The demo would be quite slower. I mean, even now it struggles, imagine. And I was talking about I think I talked about everything. And this special. Now that means, though, if you want to walk from the polygon to the next polygon, it becomes slightly bit more complicated in the code, because you don't go and say, okay, add 3 bytes to go to the next. You have an extra byte in every one of them to know the number of it. If it was a triangle engine, it would be easier in code, but it makes things much faster with certain objects. And I remember I wanted to show something else, but maybe later, as I was scrolling through the objects. But I can go to the next. Okay, we can go on. So that I've talked about a lot of things, but unfortunately there is even more work. There was even more work to be able to do polygons, to be able to do convex polygons, non-convex, glens, and so on. There is way more work from that part. I have to check for backface scaling. Ah, yeah, I remember what I want. Because I'm going to hack an object. I guess you know the clockwise and counterclockwise polygons. So depending on how you define, you pass the order, the points of the object, you could. So is it clock? Okay, one. That's okay. That's opposite. Come on. You can have clockwise and counterclockwise polygons. That's clockwise. That's with the how the clock goes. 1, 2, 3. Oh, that's okay. It says here. Those are the points. 1, 2, 3. it's the order 1, 2, 3. If you go 0.1, 0.2, 0.3, 1, 3, 2, it's going counterclockwise. And this is very essential in 3D graph because I have to render, actually we can show you. Or I can show something even more simple. Huh? Why? Sorry. What the hell? I'm in a hurry and this happens. Why did it stuck? Sorry. I think guys, first of all, this video will be. Oh my god. Oh, I click on Steam. Oh. Okay, maybe I shouldn't worry that the video is gonna be long because it could have been 3 times longer. Actually, see this quad. The way I store this quad, I store it so that if I rotate it, you're also gonna see the back face. You see? And this is because obs quad, it's there. I define the 4 points on plus minus 1. Those are the poly. I give 2 that's how you can do both faces, obviously. It goes 0, 1, 2, 3, 1 polygon, and I add the same polygon from the same point but in the reverse, 3, 2, 1, 0. So that I have both clockwise and counterclockwise in the mesh. That's how can I make two-sided, which is normal, is what the common thing you would do. And you have to see, okay, I have designed a lot of this object. That's the weird thing, except from the letters. I will show you something about it. I have designed it, and the letters weren't hard to say. I have designed it with my mind, you know. I would be plotting points. I would imagine, I should have used some tool, but I imagine, okay, I need a cube. It's gonna be plus minus 1 in all 3 axes. And then I started visualizing, okay, first polygon, 0, 1, 2, 2, 3, 2, 3, 4, 5, 4, 5, and many times mistakes would happen. So that goes minus 1, minus 1, 0. So I put my points how I have them in my mind. So here I mean, maybe I shouldn't. Maybe it's minus 1, minus 1, 1, minus 1, 1, 1, and minus 1, 1. Y is up, X is left, and Z is 0. I didn't need to add Z. So obviously, if you go 0, 1, 2, 3, you go 0, 1, 2, 3, counterclockwise. If you go 3, 2, 1, 0, you'll go clockwise. Much later, based on this information, I do clockwise checks and decide if I'm gonna render this polygon or not. And I really did. I usually prefer to store my polygons in counterclockwise. This is a tradition since my old demos. That's my preference. It doesn't matter. You could do the. So most objects where I have a. I only want to display the front faces of the polygons because it's not an object that has holes and you can see the inside. It's only the front side. I will define them counterclockwise. But here, if I want to do two back and front, I'm gonna do it like that. No, if I say, you know, you have one polygon, it's only that, and I run it, I have that, and now I'm gonna zoom it and rotate it. Op! I cannot see the other side. Seamless. Or I could get a bit clever and say, you know what? The second polygon is gonna be a triangle, and it's gonna consist only of 3 to 1. Where is it? And you're gonna have this. Oh, wait. Oh, I made some. I know what. Yeah, I need to change the number of polygons in 2, of course. Else it's not gonna even. Oh, wow, there's a different shape. So I had a plan actually. I had a plan for a credits part, but I'm not gonna do it, and it would need a lot of messes. And I had a plan that I could make some vector fonts for greetings, and the plane would rotate, and the other side will show a different greeting. So you could have an object defined with front face and back face polygon, but the back face would be different than the front face. So there are all kinds of stuff. Let me. So you can do all kinds of silly things here. You know, you could add more lines, like, okay, 0, 2, 3, 1, I don't know. Clockwiseness doesn't matter in lines. Let's zoom it. And you have crossed lines. It's pretty nice and simple, and I would play all day and create objects, and I was thinking to make some editor. By the way, the only near the end of the demo, maybe I'll show you. I decided that I wanted to design the star trip letters, and I could have gone letter by letter in a grid with my mind and do it manually. But at the end of the day, I said, yeah, okay, maybe I can throw some fast tool in SDL just for 2D plane vectors. And I did this just to design the letter. Oh, okay, hold it. I was testing something else now. Damn it. I massacred my code to test something else. Ah, now. I do this. I have an old code, and instead of opening a new project, I take the old code and I do it very fast. Oh my. Okay, I was doing something with the oscillator signs and something we were talking in the Discord. Okay, maybe I have it, maybe not. Yeah, okay. So I did some, this is a 0.012 minus 12. I didn't go for 3, 4 because I fitted the letters. Even if I have +3, +4, -3, -4, I have more extents. I just did it, try to do the simplest letter. I would go like, okay, I want to make this letter. Hold it, actually. No, I have to be careful though. I cannot do, you know, I cannot do convex stuff. That's not gonna work in my demo. I have to be conscious. It's not complete. I have to say, okay, I'm gonna make, I'm gonna make some kind of quad, and then separate polygons, and then I'm like, and I'm following counterclockwise here. Maybe this will be a triangle. Maybe this will be some cube, and so on. I can store non-convex stuff and stupid geometry, but it's gonna fail in my demo. So I have to get it over here. And then I could press, I don't know, is it FS? Maybe I pressed S. It was that simple, and I would save. It will automatically save the values. All this object data. And you see, it's kind of janky. It forgot this comma and it had to put a dB or something. Yeah, but I had this is something I did the last. I wanted something fast to make the star trip, and I'll tell you the story. This was one of my longest as pure assembly coding. Like I was working for this even for 3 months for the engine, maybe 2.5 months. Which might not be. People are working in project for a year, but to me it was quite long, especially doing only that, writing assembly, Z8 assembly, and even hard assembly with 3D maths and stuff. So last few days when I was scripting the star trip vectors and decided, you know what, I'm too tired to manually type the stuff. So let's make a tool with because it should be easy, 2D SDL. So I started a new project. I started writing the tool in SDL C++, and I felt the bliss when I started writing something very simple with mouse and so on, and drawing lines and so. I actually scrapped the same line drawing routine with a de-aliasing, which uses the similar concept as my demo with fixed point GUI lines. So when I write this simple thing, I felt the bliss, man. I felt, oh my god, what have I been missing? I didn't feel like, oh, finally, I left the tedious assembly. I'm so much slower with it. I got to beautiful simple C code. I was like, I mean, it's CPP, but I mostly write like C sometimes. I was like, I felt the bliss, and the bliss wasn't like, oh, finally compiled. I felt the bliss like compiler is a gift, and I felt like what it could be if in the 90s, assuming I wasn't very close-minded, if in the 80s, 90s, I was looking at the first C compiler, I would be expressing the pro. I felt the bliss, I felt the rare bliss of it's a gift that we have compilers, especially for modern PC stuff. And even though I was using SDCC for other things on Amstrad, I still realized that no, it's good for prototyping, but it's better to do things in pure assembly because even the memory footprint, not just optimizing, the memory footprint in SDCC would be much lower. I was already struggling with memory on this one. And one reason I was struggling is that we decided the demo to still try to make the demo run on 64K. I could have gone 128K and even store huge lookup tables for some of the division and multiplication so that or I could detect whether you have 64 or 128K. I needed more time for that. So SDCC would be a no-no, even if I wrote a lot of parts in assembly. So I went back for pure assembly. But it's one of my longest pure assembly and Amstrad projects. Usually, most of my demos is something I write in 2 weeks, in a month, and just throw away. Or it can be old effects that I did 6 months ago, 2 years ago, whatever, and I decided to put together. But this was a conscious effort at almost every day, and sometimes no, sometimes for 2, 3, 4 days I did nothing, and sometimes and I also have a technique that helps me from procrastinating. As I'm working from home, I'm getting very miserable to sit in the same office and continue code. So I get my laptop, go in a cafeteria outside in the city, order my coffee, open and start coding. And I realized this was, and I still do it, very efficient for a lot of projects. Because I start coding and if I start here, I feel like, I don't know if I'm not feeling motivated. I rather play Dark Souls or something. But if you are in the cafeteria, okay, first of all, you are more relaxed with your coffee. You look around. Maybe you open your code and you look a bit, but not do anything. And then it starts flowing. And I have been working on some 3D stuff. I have been working on some other things before, and some of these things weren't released yet. But I have done. I have been more productive with this thing. And sometimes I try it on my home. So I go to my. I don't sit on my desk PC. I go to my couch because sometimes it's raining and I cannot go, or I don't feel like, and it's getting darker in the winter. So sometimes I take my laptop and I sit on my sofa in the living room and I don't know. Open the laptop, wait a bit, wait for it to come. I don't push myself. And I always write something, and sometimes I write a lot of good stuff, and I solve problems I wasn't planning to solve. Maybe I look at parts and I'm like, oh, how about this one? Anyway, I'm getting away. What was I showing here? Uh, yeah, I show you the tool that I used to decide only the letters, but nothing else. Everything else was made by my mind. I have to think of the clockwiseness. If it's a visual editor, it's much easier to draw. And I wanted to make a simple tool where you draw the way I draw, but on a 3D grid, which I will rotate with some buttons. That's my. I wanted to make a low poly model, and that was a much older idea, even before starting this demo. So the same way. So that's the other thing. The same way I have this, and I can say, okay, I'm gonna draw this triangle. I'm gonna draw this quad and go close. I wanted to make something, a very simple interface, nothing complex, nothing to give, to sell or give, not a professional, just where I can see the 3D grids with dots in the back, and maybe the dots in the back will be smaller dots. And with few buttons, I will rotate it, usually 90 degrees, whip, 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 and was seeing the side, and somehow I will, maybe I can navigate a bit. I have to see how, and I can also make low poly objects sitting on a grid, on a regular grid, on the third dimension, so that I could design much more. And I was thinking of a tiny minimalistic tool like this. So, and that's years before doing this demo that I had this idea. I just never put my ass to do it. Anyway, and that's it. I think I should move on. So we need to check for backface culling. I just saw the object, the backface culling. I might not show much. Maybe I should accelerate things a bit. So backface culling. No, is it backface? You need to see what you're doing. There is much more, man. Rotate dot object project. I wanna say, do I have project here? I forgot to say that I don't just do the division. You see, I do the Z shift by. I have to add the position Z, Y transformation, X transformation. I have to call the mixed divs for the transformation. And before I do the transformation, I have to add the object trans X object, the horizontal, the translation. I have this object that I'm moving it around. I have to add this too, or when I zoom in. So before I do the divisions, I do that. And I just had a system where in a lot of the codes, I have this thing. If I want to do code modification, because normally I would have to read this from another value, from another index, and it would be, maybe it would be okay to not do this at some place. Maybe I don't have enough registers to, also I could read it directly thinking about. But I think this could be a bit more optimized, because this is gonna loop through a lot of points and it's gonna continuously go on the offset position x, offset position, the transformations when I move the object. So I did auto modification, auto m. I say the same. I have many places in the code where I do auto m, because I'm going to auto modify this value to have something in, and that's gonna be the position. I'm gonna do it from outside before even calling this one. I'm gonna read the object position, which are probably the object trans x, y, z. These are fixed point, if you see again. These are 64 units on z, far in the distance, by 256. 88 fixed point. This is xy. My input or my script will manipulate this object. This is object 0, object 1, object 2, object 3. Now we have one object, but if we have many objects in the scene, and I just made 4 for now, because I didn't need more than. Okay. This is the code of the interactive. The demo had 8 because I had the 8 letter. I had more. I just removed few of them. And this is the object sorting later, because I sort the object based on their Z position later, so that back to front I choose which object to render. I have object sorting and I have individual polygon sorting for certain objects that would look wrong if I don't sort. There is more there. Glance enabled on off. Now I alter some of these things with the input now. I can enable disable glance, but glance only works on certain objects. Current object, if I get more than one, I will change this value with the script. But now non-visible object is 1. I mean, if you say non-visible object 2, okay, what do I have? I have 2 objects here. I only rotate the first one. The other must be the cube. And it's not even rotated. You see, that's the facility of the. So my engine doesn't just display one object. This interactive thing displays one object, unless I program more interactive keys to add more objects in the scene. But I didn't need it. So there are all kinds of things. It's just the object data here. There are kinds of things on other. And so even the loop project points. Okay, I transform and then divide by z. And then I store somewhere. I do some checks for clumping. There is more. There is way more. There's way more functions. And I try my best. Some of these functions are big to reuse register and not have to use much memory for variables. And there are places where I use EXX, EXAFAF tonos, IX, IY. There are places I use the stack. Here you say disable interrupts, get the stack back, enable interrupts. And I had issues with the. However, I'm enabling. I have to talk about that too a bit. I'm doing many dirty things. If I disable the interrupt in this inner loop, the interrupts would go way beyond, and the music player would be wrong. The color, the timing, I have to color to count the times elapsed would be wrong. So I'm doing. There are places where I really disable the interrupt. Here I enable the interrupt and start using the stack, even if the interrupt could corrupt some of my things. I might talk about this later, but there are cases where I can kinda do that. I only disable to set it back to normal and then enable. The original code wouldn't have that. It would disable and all of this would be disabled, but I would realize I couldn't have as much stable interrupt. But now I enable it in purpose, even if I have altered the stack pointer and I'm gonna push stuff. And there are places I can be dirty. Even if interrupts happen in the middle, it's not gonna corrupt or make it crash, but it's kinda dirty. And I run into problems. I'm gonna talk about this later. So this is important. Find the raise min max area. Okay. I was talking about the projection. Sorry. I have to go fast. I have to really go fast. But okay, the video is gonna be big. I cannot avoid it. There are so many things I want to talk. Maybe my Julia fractal video shouldn't be so big because it was just one effect. But this one, project points and draw. I have draw object wire and draw object fill. Draw object fill might be. So there is an important part. I might show it to you. An extra overhead with 3D graphics. Now, if I was rendering a plasma, suppose this would be a plasma. I could just render on top, and my next rendering would gonna erase what's previously. 2D effects would be easier. But if I'm rendering a polygon, if I render an object with many polygons, okay, suppose this is an object, not a polygon, or maybe this. One way would be like, you know what? Erase the whole screen every time. Just erase the whole screen every time. But this on CPC, even with fast push, will take more than one VBL alone. I would be screwed. So one way is, okay, maybe I'm displaying an object in the center of the screen. Maybe my whole demo, put some Q. Maybe my whole demo is that. Maybe my whole demo is like, hey, here is an object in the center of the screen. Then I would know to always erase that, always erase a small area, But I would know that my object is that, and I'm doing a little 3D effect in the center of the screen, that's it. So I have a more elaborate system where if I move this object, it always keeps tracks of the previous min-max area, and that's what this does. So at this point, we call to draw the object. And we have stored the previous area of the previous object. And now, because I'm doing, okay, now I had to add extra code because my object might go there. I had to first call to club min max area in case the points are outside. And maybe I have a bug because when I go there and things are screwed up, it means that the club min max area has a bug. I have a bug on this side. I have an actual bug on this side. It doesn't happen correctly. That's why you see this garbage, because the erasing of the previous min-max area is faulty there at the edges. But it works well. So I had to add the clamp. This is an extra thing when I started adding clamping. And then from the clamp points, I will find the min-max. I will just do min-max checks full register, very simple. Blah for every point, and I will store where do I have that? I have that. Now we are on the I'm gonna open the internet. We have that in the graphics, I think. And erase min max area. I had 8 for every object because if I have more than one object, if I have an object that is here and the other object that is there, I don't want to erase a big min max area. I want to erase a small area here and a small area here. However, I'll tell you something. I made a secondary function where I erase a unified area. If you have many objects, like one object here, one object here, one object here, why not do it once? There is a bit of an overhead with the erase if you erase separate areas. But if there are small objects that are far away from each other, it's better to erase in separate areas. So I had an elaborate system where I stored the coordinates from the previous. And why do I have erase min max area 1 and 2? Because of double buffering, because in the current frame I have to erase where the previous polygons were. You know. And you also see it if so when I transform stuff, I have to store the previous area so that later I need to find it. Man, there are so many stuff. In render all objects, who is calling render all objects? Probably the script. Who the hell is calling render all objects? I have a script here. I have the script. Oh, come on. Don't rename it. So this is the very outer loop. I call the inputs. I script the input for the keys. And here is the render all object that is doing the transformation, everything. And before in the beginning, I erase the area, but those polygons are what the previous frame has drawn in the next frame buffer that we are just gonna get into. So there is this whole thing, and who's calling script? Main is calling script. And this is the frame loop, GR frame. It doesn't have an escape. Where I have some CPU. We are gonna see. Forget about that. Yeah, I'm doing the vis. I'm waiting for the vsync. They didn't enter the script. The first thing it's gonna erase. But because previously we swapped pages in the CTC, we swapped between the two double buffer. Where the vsync will show the previous area, and we are gonna erase the one that will render later, which holded the previous object areas as the object animate, and we want to erase everything that was rendered a frame ago. So there's this whole thing. I'm calculating frame rate. This is the very main, by the way. I'm doing initialization, signs, extract the tiny fonts. That's for the frame rate counter. I added now, only now. Yeah, I might need some object stuff. And I will need somewhere, even before, an interrupt routine and a callback. It might seem that I do a lot, and I have the 6 splits, 300 Hz 6 screen areas per VBL. So in one of the it goes 0, 1, 2, 3, 4, 5, 0. So that I know at what VBL I am. It seems I'm doing a lot. All I was doing here, previously I was playing the music, but these are commented out. These are removed from this. It's only on the demo. And I have various things. How many VBLs have passed? VBL ticks. How many seconds have passed? I might in the demo might use some of that. And I might have added some extra stuff from the frames per second calculation. So the other thing with the demo, obviously, is that you have this, you have this option. It's slow, it's fast. You see, it doesn't do 9, 10, 11, 13. If you go fast, it's gonna go faster. It's gonna go over VBL or under. Actually, I have, let me see. Yeah, I have some kind of CPU. Okay, we're gonna loop a bit. You're gonna see the future stuff I have. Okay. Now, for some reason, the engine is still not good, and I spend a lot of BBL even with simple object, unfortunately. You would see that an object so far it should, and it's very variable depending on the edges. You would get easily 50 frames, but it goes and you get 25 and okay, I screwed it up, and I had this CPU bar thing to experiment with it. Besides other way to camera, and as you see, the the rendering, depending on the option, can jump from 1 VBL to 2 VBL to 3 to 4 to 5 to 6. Okay, and I had to have some ticks so that I have a stable animation. Back in the time, it's like, okay, it was like I'm running a plasma, it runs stable at 2 VBLs or 3 VBLs. Okay, I'm gonna increase a frame counter or something. Maybe I increase the frame counter twice if I want to move it faster. But now I decided, and I'm more confident with Interrupt. Back in the days, I wouldn't even put my music, the music playing in there. I would call it manually, even in a variable demo. Do you remember Xcode where sometimes the music was going slow? There was a bit of scratch in the music because I was calling it manually and I was calling 2 times, 3 times, 1 time, 4 times, depending on how things come. It was, but now I know in my other non-interactive code I also call the music and I changed the color of the logo. Just after the logo, I changed the color for the other objects. So I'm doing some more sophisticated stuff. And these were very useful for a more constant frame rate, regardless of how slow or fast the 3D are. Very helpful. But I diverted now and I forgot what I was talking about. Damn, I have to remember. Oh, the back face. We haven't even. Okay, I'm gonna do some favor and I'm going to really because I'm looking at that and I remember a lot of things. And I needed a stable in the wraps, and I had some issues with using the stack pointer at times, and I found various techniques. Okay, the deleter, sorry. I have this thing with the erase to, when the object is moving, I don't have to erase the whole area. Or render the object in a big buffer and copy the big buffer. It would make things much slower on the CPC at least. You have to do dirty rectangles basically. This is like dirty rectangles in a way. And I call the min-max area from the erased data from the previous frame. I have a case where either I loop through all the areas or I have a unified area. So I had a flag where I would accumulate the coordinates from all the objects in the scene if I have more than one object, and have a unified CLS if the objects are close. Because here I'm doing the race with a bunch of push per line. I find the area, and this is gonna be an auto modification. If the horizontal width is much smaller than full, it's gonna jump. It could jump here and do these lines and then escape. So I do some auto modification based on the size. It's a pretty fast erase. But the only thing is, every line there is a bit of overhead outside, and every line I have to disable interrupts. store the SP, use my own SP, get back the SP, enable interrupts in case that an interrupt happens. Because if I stay too long here, the interrupt will be delayed so much that I will lose the track. The music player will be wrong. I will lose the track of which of the 6 areas of the screen I am through the counter. I will lose the ticks and everything. So here, every line, there is a bit of overhead. But if you have bigger, it's okay. And I will tell you something. Got CPC. When I made the demo, I'm improving on that. We're gonna have a pattern. These letters were very slow. They were very slow for many reasons. There were many objects, of course. I have to recalculate a lot of matrices. And I did quite many optimizers. And the initial part, the one in the party version, would calculate 8 separate erase area. Like the area 1, area 2, area 3. And those are very small and they are very close together. And it would have overhead to push and pop for small lines and disable the enable get the address again and so on for 8 times. And I realized this thing, objects are always, I got unified in a big area, and so I added later, this is not on the party version, the unification, so that the min max for every point of every object in one frame is done collectively in one, and then I have a big erase area, and I don't have the overhead. Get on off for lines, store in the routes, get a new address. So it would do a big push. Then disable, enable interrupts, get back the interrupt, disable, enable. Okay. That give a lot of boost. And the other thing I didn't know is I was writing the demo fast, you know, deadline and so on, and I would be using. There was more junk actually. There was more optimization I did. I would be using this for all objects, which is fine for most objects. And I switched it to this one. Okay, normally I can even improve by doing that just to calculate x, because they all rotate over x. But even this is, maybe I should do that. The thing is, they are simple objects, but for every object, we have 8 objects, it will recalculate their individual matrix and do all the multiplication for x, y, z, even if there is 6 rotated. I might correct that more. I might make a pure calculate matrix, but I already switched for those objects only from this to this, and I had a flag. And I was getting, these were very slow. I would be in one certain frame. I would be losing 3020 noise cycles. Then I went to 280 noise cycles. With that stuff, I might have gone 198 in op cycles for a selected frame of this letter where I posted it, and they kinda gained 1 VBL or more, maybe at least 1 VBL, and they are kinda smoother in the final version that I haven't presented yet. So there are things like that. There are things like the erase area. So this logic, use unified CLS area or not, or use per object, and I'm also using something at other places of the use unified area, and some other place I do something. So if you enable a unified area, all the objects will use this array means max area. They will ignore that, and it will be unified at the first slot, and there will be. That's the number of areas. This will end up being 1, so it's gonna get the min max. That min max. And it could be either here or here depending on the double buffering on the flip-flop, of course. So that's something I added later, because even after releasing the demo, I was looking and if there was something relatively simple, I was motivated to improve it. And I still was talking about I'm gonna go very fast with that. Sorry, it's gonna be like this from now on. I try my best to talk as fast as possible. But I'm lost now. Calculate matrix, draw current object, draw object 3D. Draw object field. And this is where I have to loop. Find the range minimum, find visible polish. There is a short polish. It's getting too complicated. The find visible polish wires is also important. This is small and nice. But it's calling visible. This is very straightforward. Now, I have found some code. It has to do with dot product or cross product or something, but I should have studied this. This is a code I use many times in my 3D engines, and it might be a projection dot product or cross product projection. Okay. So there's a mathematical formula that gives you a value. It can be positive or negative. From the points, from 3 points, the first 3 polygon indices, and it can tell you, and it involves, this is the point I couldn't escape using moles. It involves moles. It involves 2 multiplies, and the result will tell you if the polygon is visible or not, if it's front face or back face. And previously the clockwise or counterclockwise result will flip-flop the result. So I know if n is positive or negative after I do this. I know if I have to add this poly to a list of visible polys or not add this poly. I check the 7-bit for the sign. Those are nice and small routines, with the only disadvantage that I have to waste some time for every polling to do. And here I have to do it even for the polygons that I'm not gonna render, that are gonna, because I don't know beforehand. Although I have in my mind some future ideas to even avoid this multiplication, or partially avoid in some cases. That's something for the future. I'm not gonna design. Those were nice at the end. They seemed scary. Those were nice because they're very ordered and using a lot of the registers. I'm reading from memory here because I have to read the points. I have to read the 3 points. And I just happened that they fit exactly. A, B, C, E, D. And here I can give away HL. Here I had to not use HL because this is the one I read. But finally I read on L the HL because now I don't need it. And then I do the subtract. It's so beautiful and nice. And it could have been much worse. So these are the things I enjoyed. And I might have another thing. Why am I adding 2 times? Maybe an offset. Find base of poly data. And here's the thing. This backface culling tells me if a polygon should be rendered or not. And when I did the wireframe, let's put this one. the nice thing with the wireframe, which I will enable, and I can even change the palette for better ideally. I think some colors don't go too well. Maybe this is nice. You see that I do some kind of occlusion also. I'm not just rendering. I'm not rendering the back lines. And the way I do it, unfortunately, this only works for convex polygon objects. For objects that a polygon could be partially crossed by another polygon and not fully hidden, you have to do something else that I haven't done before. It might be much more involved, much more mathematical. You might have to do intersections of polygons with polygons. I don't know. So I never done. But I did this only for convex objects, not every object. And previous I had a wireframe more where I also displayed the bug lines. I displayed everything. But that's nice because it feels like it's a solid object made of wireframe. And I have a fine visible polish wire here. This works based on a table. Simply, I could even see it here in the input maybe. No, on the screen maybe. I have to just create relations in 8-line polyrel data. It's not. I have to combine the fine visible poly, even if I don't display polygon, will tell me, and maybe I don't call this here. I might do something else. See, I call visible poly calc here. That I do the thing. I also call it here, but I use it in a different way. I might do some comparison here or something. I don't remember. But generally speaking, yes. In the initialization of the objects that have wireframe, this is just running the initialization. It doesn't run. It just searches through the object data and finds the connections. Finds the connection that a reverse connection that says line 1 is connected to polygon 1 and 2 or whatever. Line 2 is connected to. So I just run some dual loop through the object data and just find connection, and I do a reverse relation. This line is occupied by two polygons. So later I loop through every line and I say, okay, it has polygon 1 and 2. Let's see if polygon 1 or polygon 2 is visible. If neither of them is visible, don't draw the line. If one or more of them or anything is visible, draw it, and that's it. And that's how this works. That was nice and simple. But yeah, it was a bit involved to do this. You need line poly and loop through line poly. This is where I might be storing. I might loop through some object data and compare some points and see. I'm doing wild stuff. This looks wild, but it's working. It's just some search. Okay, let's go back. Yeah. So I have to go back because we left now. And that's how I do the. Backface scaling, and then I realized, okay, I'm gonna have to run some. I will show you something. I have some objects here that this one. You see there is an issue with this one. And when I press a button, because it doesn't do polygon sorting, so that objects that it's possible for a polygon to hide another polygon. Also, if I put wireframe here, you get none. I have disabled the wireframe except one line. Let's move on. We will see. Even that. Oh, this is a nice example. Do you see that sometimes the polygon that should be in front going back? Because I'm just rendering the polygons in the order that they come. And if you have objects where it's possible that you have to sort the polygon rendering from back to front, and we don't even have Z buffer or something like that, it would be more involved, and we just need to do a sorting from furthest polygon to closest. And when I press a button, I enable this, and now it's perfect. Now this object, whether I enable it or not, it's not gonna matter, because every polygon will fully hide the other polygon. The way they are objects, convex objects, they say. They don't have a save that you have to do that. This and this and this, most of them are common. But this one looks horrible. And now, let's even pause it here. Because I'm not sorting. But when I sort, dang, not sort. And now it's perfect. So I realized I had to do this for those objects too. And I noticed something interesting. Do you remember the torus? Now, the torus. I enable, disable. You see a bit of over. There's a reason there is a bit of over. But that's I realized too late that the torus, I thought it would need sorting because you have polygons that are hidden, but it happens that it doesn't need sorting because I arranged the polygons so that the ones in the inner circle are defined first and the others outside. And it happens that without sorting, it will render the inside and they will not coincide. So there is some kind of topology that for some reason the torus doesn't need sorting, even though in the party version I still enable sorting for the torus. That's interesting. And by the way, here is the more detailed torus that I never ended up using. Because I thought, okay, it's cool that there are more polygons on an 8-bit demo, but if I put it far away, maybe it'll get a bit faster. So, okay. I'm doing the sorting. Oh my god, I need to go fast with the sorting because it has a bit of explanation, but it's easy. I have to say, the sorting is not quick sort, is not radic sort, is not any of it. It's a different idea. It is a dirty idea that it's not O(n) squared, it's not O log n. It's a linear time. It's an O(n). It's a very, very simple slotting. It's very light, and I use it on 3DO projects. I discovered this sorting from two things. I discovered this sorting from OpenLara 3DO. As I am in the community, I was watching OpenLara 3DO. The code is, and it was using some kind of technique that uses this sorting, polygon sorting, polygon per polygon, so that it knows which. And it works with linked lists, a linked list with buckets of Z ranges. And I found a paper that this was a very common technique. It's a bit dirty, and if you have very complicated polygons, you might see some polygons to sometimes disappear before others. But in my case, it's okay. Or we see it. We actually see it in. There is a bit of, depending on how you do it and how much memory you allocate. An object that I didn't put is this torus. Now there is no sorting. Now I'm gonna enable the sorting. But look, sometimes some polygon flip-flops here because it's not very accurate. So these techniques could, yeah, but it's hard. See, yeah, I saw it. Wait. Ding, poop. There is a reason for this, and it's also a memory reason. If I made a bigger size, I could fit it. I reduced the size of memory for some reason to gain some memory somewhere else. The size of the Z bucket. This technique I read was very common in PlayStation 1, in some PlayStation 1. This was a very dirty way to sort. Could be even faster than quick sort or radic sort. Okay, and I'm gonna, the simple version of it, my Z goes from 0 to 255. And I need to find maybe the center point, the Z point of each polygon, and I need to sort. But I don't need to do some non-linear set, some quick sort, something. I don't need to do some non-linear, let alone n squared. I want to do an n or something. I want to do some dirty, very dirty thing. So I'm using buckets, 0, 15, 16 to Z buckets, ranges. 32 to 240 to 255. Now I choose range of 16. Maybe I choose the range of 8. Maybe I choose range. The more crude it is, the more bugs of this you will see. I think in the demo I used 0.8 and then I saw 3 bits for it, and then I raised it to 16 to have less buckets, to reduce the memory a bit. But maybe I did it now in this interactive thing, or for the final version we might be finishing, I don't know when. So you calculate, suppose you calculate average Z from triangle points, and I'm gonna tell you the other dirty things I did for that. So normally it would be P0. So you found, okay, a Z value in the center, and that Z value, I'm gonna shift it by 4. So I'm gonna know the index of which bucket I'm gonna place it. So now here I put the polygon index, polygon 0, polygon 1. Maybe polygon 2 goes here, polygon 2. And I'm increasing a counter. I think before that I have a number that is 0. And then it goes to 1, 1, 2, 2, 3. So I also have the number. And so on. And maybe here it's all 0 because I don't have more polygons. But I will have to know that I filled this bucket so that I only search in this bucket later. And now, if I go from highest bucket, from this one to this one, and render first those polygons and then those, it's gonna be some crude back to front Z rendering of polygons. And all I did was shift to find the index and just slot it there. Maybe get the index and add it to know where I'm here and here. Okay, maybe I should do it in... I don't know if I did it in the most optimal way. But just slotting. There is no quick sort, bubble sort, radic... I mean, radic sort is kind of like slotting too. However, these are 16 buckets. And right now I have 16 slots. Actually, no, it's 15. 1 plus, because I must have also the number of. It's like a list that says, okay, number of items following this, and these are the polygon indices. Okay. So 16 by 16 is 256 bytes. But what happens if this and these polygons are very close together? You might see bugs like I don't have it anymore. Right? At some rare cases, micropolygons go in and out. And you could see that in PlayStation 1 games that used this, or early PC games. You could see sometimes some little, but in the majority, it was doing the trick without having to do some ON square or O log name, or even some more optimized, but still kind of costly for big numbers of polygons. And it's so simple. But here, because I have few polygons, I know that I'm never gonna add too much. I'm never gonna overflow. So that's not good for generic. Now, on 3DO, this goes a bit different because some kind of struct that would maybe have a value and a linked list to next, and it would go to some null pointer. So these things were in a linked list, so they could be much higher value. Which, because I had object with a lot of polygons on 3DO. I have object with 500 polygons, 1,000 polygons. So I couldn't just have many, and also on 3DO it's not 0 to 55. It might be 0 to 65. It might be much larger range, and I need a lot of buckets. Unless you make your buckets crude and you start getting many disappearing, flipping polygons. So that's what I do roughly with the Z sorting. Yeah, I have the slot, min-max slot, sorted indices. I have some area in memory. Sorted indices from 6200 to 637. And actually I'm dividing the slot by 8, 0, 3, 5, 2. I was doing even more precise. And I would be needing 2048 bytes. Now imagine in a later, in 32-bit hardware, where you have plenty of memory for these things. And it works pretty well because I have big polygons and I don't have many small polygons close together. And again, there will be bugs. And also, I'm cheating a bit. Because, I removed it. Okay. I would have to find the sender. If I have a triangle, I have to do that. Oh no, I have to do a division. If I have a quad, do you remember we have nigons? Oh, at least this can be a shift. Also, it could be easy to pre-calculate this. But what if I have a pentagon, hexagon? Do I need to do... No, I scrap it. I have this rule. I'm gonna do that always. Shift by 2. I'm gonna do that. If I have a triangle, I'm gonna do that. It's a bit of cheating and it doesn't give you the center. I'm gonna add the last point twice. It doesn't give you the center, but it gives you roughly on the plane of the polygon the Z position. It gives you roughly some Z that is very related to the polygon, and it works. So I did that. I always divide by 4 in case of a triangle, and in case of more, nope, I simply stop adding more points. So in the case of in the case of this, and now that can be a bit dirty. In the case of this, I go from 0.0 to 1. Put a nice color. I'm just taking points, not edges. I'm taking this point. No. Oh, damn it. I'm taking 0.0, 0.1, 0.2, 0.3. And you see that it's a bit janky and you are gonna run into problem. And the Z coordinate is gonna be here in the center here. But it's roughly, it's not gonna be precise. If I make some complex Nigon thing, you're gonna see things flip-flopping. And I do this. I do the same thing with the backface calling, of course, where we have to do that calculation. I do with edge 0, 1, and 1, 2. But that's sometimes so there are micro problems, but it's like, okay, it's a all retro engine, and it's expected, but it mostly works pretty well. And that was the sorting and all those kind of tricks. So I did such kind of silly optimization and crude, not precise things. And finally, I think we went through the. Oh my God, we have more. Oh, the Z slotting idea, I should say. And we haven't gone to the polygon. Oh my God, maybe. I think there are things in the polygon. So I'm collecting the points. Okay, back face culling the points I need. When I do the sorting, I sort only the front face polygon. So the back face checking already discards a lot of polygons. So I have fewer polygons to sort, which is even better than doing sort all the things and then do the back face culling. And we end up in the sort policy. Copy sorted policy release. It was really boring. When I see it, I'm surprised by myself. And if I disable the polygon sorting, I don't do it, and I just get them linearly somewhere else. I check the glance enable, and I'm setting the. Yeah, I have the glance thing. I'm gonna show you. I can show you the glance briefly. Ah, shit. Oh God. You know, most objects that are not because the glance will change thing to a NOR. I'm gonna show you what happens. So this is the glance. Now, also now it's not sorted. If there is no glance, you need to sort. Now I have sorted it. It's very. I put it very close up. It's very slow. Because they are front face and back face, there are more polygons. Now, if I enable the glance, the thing is, with the glance, you don't need to sort polygons because whether you render it back or forth, they're gonna all together and they're gonna produce the color. So even if I sort or not, it's the same. And that's the glance. And that's also an object that is really cool with the glance. And if you change palettes, some of the colors fit, some of the colors don't fit. Maybe this is nice. I might like this one. And do you remember this object that while it's one quad, by defining both clockwise and counterclockwise, the same polygon in reverse order, I get both sides. And I also set a different material for each polygon. The same way is how the glance works. In order to do the glance, you have to, the polygons in front have to define twice. So they are twice the polygons. And that's one reason why it has to do the front back face checks. Although I'm thinking now it shouldn't do the front back face. Maybe I disable. Okay, so there are always things like, oh my god, why not just render? I just thought of an optimization, a stupid thing. You know, because the engine is a generic engine, it calls everything. When the glance comes, I still call the thing to sort the front face and the back face. But at the end of the day, every polygon, just like the quad, I have the polygon 0, 1, 2, 3 and the same polygon in reverse, so that it has both sides. Oh my, all this multiplication for the check if you surrender or not. I have to modify the engine. Because in the case of the glance object, they are always defined. This is the glance object. So that 803, now these are triangles, 803, 308, 874, 48. So front face, back face, front face, whatever it is, and they are all triangles. And the materials, color 2, 3, color 2, 3, color 2, 3. So the back face have 2, the front face have 3, and so on. And I just realized I passed this object with 24. It seems like it has 12 polygons, but it has 24 because you define the one. This is pretty complex. I pass it through that code that does 2 multiplication to check if we should really render the front or the back. But we end up rendering both. No, okay, maybe I should do it. Because the polygon in the back is the back side, but it also has a front side, but you don't see the, okay, it's not, I don't think I could optimize this. Because this is a different polygon, this blue, bright blue, than the purple. It seems like the same polygon with each side. These are 2 polygons. But again, it has to run the algorithm through 24 polygons with the multiplications to decide that it's gonna render 12 of this, or however they happen to be. But some of them will be the front face, some of them will be the back face, and that's how it works. Wow. Okay, no, so sometimes I have this idea, oh, I was doing more work, oh, okay, maybe I wasn't doing. Maybe there is something to think there. So you have the polygons, and the polygons are quite a pain in the ass. But when you get them, 3D poly, and it has some huge code, some simple set polycolor. I do some unroll loops for the polygons for the big loops, so I do some as much optimization as I can. For example, I have this is just a macro, and the macro is LDHL, A, increase L. I'm in 256, 64 bytes more, so I do incal freely without care. So I write the big block and I increase. But, and that's the filling of the edges. That's not the start of the polygon. I have to go here later. And also, you know, a mode 0 pixel is obviously, you know that a mode 0 pixel is not gonna be a mode 0 byte is not gonna be a pixel, it's gonna be 4 pixels. So I have this is the CRUD inside and there is gonna be a jump that I will auto modify depending on the length to jump here or at the end. And there are some check if the length is bigger than this one, smaller or negative or whatever. Don't do this because something went wrong. Because you are gonna jump from here to here or something, or you know, there are all that kind of stuff. You have PB set, PBR is for the so there is more work on the glance exclusive, or it says LDA comma B or HL. Why does it say LDA? Maybe we load something on B. Why does it say LDA comma B or HL with B? Okay, B is a starting value. It might come from the material. B is the value we are gonna write. We load it in A, so we OR with HL with the background. Now this looks in the videogram, and we write back the exclusive or the blended value again. And of course, the glance happens like this, like color 0, color 1, color 2, color 3. There are 2 bits. Polygon 1 is 0, 1, polygon 2 is 0, 0, so the result goes 1, 1, and I set up the palette accordingly so that the combination of the OR of the bit is gonna be the palette index 3 from palette index 1 and 2. If I did it on mode 0, I could have bit 1, bit 2, bit 4, bit 8. I could do 4 layers in the 16 colors maybe. And yeah, so the bulk is here, but I have specialized code with some extra plot bytes, left, right, masks, and so on to handle the edges where it's not for, in the cases it's not for full bytes. The right edge and the left edge is a byte where I only need to fill 1 pixel, 2 pixel, or 3 pixel, for example. And there is a special case where the code looks ugly, unfortunately, and maybe too bloated. I'm in the line here. There is a special case where, and that's on mode 0. What happens if you have 4 pixels, but the polygon is x is 0, 0x, 0, 0? The polygon is filling that. Normally we have the case 0, 0x. X is that we have pixel. And if it's like that, it's gonna go to the central area where it's gonna write bytes. And then on the other side, it's gonna be, when I put x, I mean filled pixel, and the rest are empty. So you have the regular case. But what happens if you have some micro polygon where the coordinate is from 1 to 2, so it's like 0x0 or 0x00 or 0x0, and I was looking at ways to do that, and I was thinking to create special masks like this for special cases, but I think I scrapped this one and I did something else with some plot bias that was here. Unfortunately, if I do this in mode 0, you are not gonna have this special case. It will either be 2 pixel or 1 pixel on the left and 1 pixel on the right. There might be special case. Yeah, oh no, there won't be. So this happens rarely when the length of a polygon is really, really small and less than 4 pixel, and it's very blow. For some reason, it seems very blow, but I tried to comment it out and skip, and I realized, okay, it's not killing my performance. Because very rarely you have some polygon edges, but it could be written smaller. This might be something on the left, and I'm doing a lot of auto modification for the color, and it is a bit ugly. And I suspect that. So what happens? This is filling the edges. It seems that the polygon filler it's a lot of time, but it's not just the filler. It's the all the junk I have to do that could have been written better, maybe. In and out. And also, before I call the fill edges, I'm doing the draw poly is very big. And this is okay. This is the crude big brute force thing again. Okay, this is where I have to walk in a polygon edge, for example. I have to walk vertically. Suppose this is 0, here 1, here. I have to walk vertically on a pixel, but x could be 0 or 10, 9.5, 9, 8.5 in fixed point. So that's the part where I have to walk vertically in a big loop for this edge, for this edge, for this edge, and start storing in an array left edge here 255, right edge. So later I go to psi equals 0 supposedly. Now that's not 0, it could be 10 if 0 is here. If it's the y coordinate of the screen, and I have to read from left edge here 0 to right, and so on, and fill the horizontal lines. Okay, so it could be from 10 to 10 to 11, suppose, from 9.5 to 11.5, and so on. I have to work with fixed point interpolation here and here to find the left right, so that I know which scan line to render. Maybe leave it here. Okay. And this is just the point where I finally know the interpolation step and the starting x and y position. Where is that? And that's another macro that says read. So I have HL, which is fixed point. If I read it's like I got the, this is 8 fixed point again. That's how I do. Read the integer part of the fixed point, store it, increase in our array, and add to HL BC, which is the step. BC is the fractional step as we walk down the line. As simple as I could do it with this one, and this is something that will repeat. This is gonna waste a lot of cycles, but it's done as long as I can. And again, there's an auto modified, and this is not gonna jump here. This is gonna be modified depending on how deep we want to jump. And I have removed some lines. This goes 192. The comment is not. I remove because my edges don't go so big. But if you remove too much, I was doing some check, min-max check to know in the demo my edges are not gonna go longer than something, so that I gain some memory. And this is the bug, but before the bug, it loops for every poly, for every edge. There's so much stuff, And this was written gradually. This was much simpler, and there were more things I added. I do something with this, so depending if the polygons are sorting. Okay, that's where I get the data. That's not so important. Now, this is a big idea that and I think it makes the code much, and maybe I will rewrite it in another. And also, I added things because I have to clamp the lower edge. I have to. So what you see is a monstrosity that I started much later, and I also inlined some stuff that I had separated. And there are places where you have to compare the points, sort them, sort an edge depending if y coordinate is from point 0 to 1 is greater or not. So you decide whether you swap the edges or not. Now, and I'm using EXX because the points on the EXX are having the high byte of the. When I started adding clipping with the edge, the points would go over. So I have to get high bytes and swap them too. And sometimes I do some invalid. It's a bit of a mess, and maybe I'm wasting a lot of time even before starting, going through the edge and filling the edges. No matter how much I try to Z80 optimize. And I even, okay, because now I have to do some extra for the clipping. The thing is how we calculate the slope. How we calculate the slope? We have to do a division. You have to divide. You have to divide dy via dx or dx via dy in your edge to know as I move to the next pixel what is the fraction of the fixed point fraction of dx. We have to do it. Now I optimize it a bit with a mixed division. Sometimes depending on the steepness you don't need to do the full. You remember that mixed. You don't have to do the full. You can do HL by E. You don't have to do the BCDRD. If the result is gonna fit in a byte. If it's gonna be a very steep thing where the result is not gonna fit. Also, it is signed on the left because you can have a positive x and a negative x divided by y. There were all numerical considerations here with making this work, all kinds of bugs that I fixed. It's such a big project, man. But I have some edge cases that takes memory, some kind of edge case logic. Which is this? I'm gonna describe it very simple. Or maybe okay, let me run it so that I get some good object. There is an ideal object, this one. Let's no. Suppose you have that. For every polygon, where is what the hell? What? Where is? What's going on? Oh, okay. For every this is a triangle. For every triangle, you have to calculate to walk through this edge, walk through this edge, walk through this edge, and you have to divide dx via dy to find as I move vertically 1 pixel how steep the horizontal coordinate moves in fixed point, so that I move and create the edge, fill the edge tables for later polygon filling. So I have to do one of these costly divisions for every edge, but I noticed at some point, wait a minute, when I go to this polygon, I have to do this one, and this one. And I always sort my points from top to bottom, so it's still gonna be this one. The division will be the same. So wait a minute, they're common. And even here, this one. So there are edges that I'm going twice because they are two polygons there, and I'm doing the same division twice. Okay, so I started noticing, and I had an idea which made my code more. I did gain something, especially in the heart. It was kinda worth it. It was like object that I froze a frame. From 95, from 65 to 63,500. From 95 to 92,500. So there was a game. It wasn't that much because there's waste in other places, and the division could be depending on the type. $140, $290 NOP cycles. Moloch 8x8 sometimes goes 75 to 90 cycles, maybe. I mean, I don't remember. That's roughly the number, so it goes kind of significant if you make a lot. But that's why I didn't. So okay, I avoided the 6, 5, 10 division in some complex of that. Maybe I avoided 3 divisions on the 3D cube from the 6 or something, or more actually from the 9. In some position where there are a lot of visible polygons with sharing edges. So I devised the whole system with some kind of extra memory. Edge cache addresses guy. Now this is why I can't load some big object with over than 32 points. Because now I have some cache system, which I even try to do it in a way that I don't spend so much CPU time just to traverse it, to search. I don't search. I do the indices in such way, in a bit more memory way, so that I can instantly find. So when I'm given a polygon, I calculate the slope, but first I check in this index table, and it kind of works like if this is index 2, oh god, and that's 3, and that's 1. The point indices, suppose it's that. I store 2.3 calculated slope. So the next polygon does a little bit of extra. It checks, and I try to do the search fast. It's not even a search now. I have some regular bucket thing, so that with few left shifts or adds I can go to the place with a bit waste of memory, so that I see, oh, this polygon, I do the for 2, I calculate the slope, I store the slope. That's kind of big. But before that, check first if has it already. So every every division I do and to calculate the slope of the index, I store it, but before that I check, and initially these are all 0, so it says it doesn't have it. And those slope are 16 bits, 6.16 bits, so I have to spare 2 bytes per each. And that's it. So during the whole thing, if an edge has already, I'm caching the edges, I will reuse it and avoid the division. And it did gain me some, and I was putting breakpoint to see that it really works. It doesn't do junk stuff. Now, if it was doing wrong stuff, it would get totally wrong slopes, and my polygons would break. It would render the totally wrong stuff. It rendered the right stuff, and it really found. It didn't, because I could have made something that I thought it worked, but it did nothing. It did skip some division. It worked pretty well. And at the end, I have to store which addresses I placed and go and erase it with zeros or something. And I didn't want to do a full loop through this and erase everything, so I had to store cache clear address linearly so that I know how, and I also stored where this address puts so that I don't create the indices again with shifts and go and find. It's a bit of convoluted thing. It's a very interesting thing, and I realized something right now. I realized that I'm doing this caching just for the division, but this whole thing is a very long thing with a lot of waste, doing much more than the division, and walking through the edges and storing, even walking through the edges. The thing is, if I kept somewhere the calculated, the things I stored here to the left right edge in some additional caches, I could even retrieve that and do nothing. The next index, this is what I'll do in the future. You say, we have already calculated, and here is the list of values. I could have some packed. So I would skip entire section. It could be the division is just a small number of cycles compared to what I'm doing. That has become very bloated. So I just realized that. But that would need, if you have many, even if you have 32 edges or more, you have more than 30. 32 are the indices of the points, but you have more combinations. You would need a lot of memory. That's the only problem. I couldn't have done it for this demo, but I could do it and test even in this interactive. But I would have to massively alter the code. Maybe we'll see, or maybe not so much. And I would have, if I store this for left or right, because when I store this previously, depending on the comparison, depending on left or right, I might either store to edge right or edge left. I put this register that I use later. Imagine, in all those things from up and down, this is one of the more convoluted. I was using EXA, FAF tonus, I was using EXX, IXI, and through the process I might know, oh, here I use this register. Oh, now here this register is released. Let's use the other. And it's very convoluted. If I make a change, things will crash, will go wrong because, oh, I was using this register below. It's it's the most convoluted thing I have written. Well, I don't go and say, okay, I'm just gonna use the memory for variable. I fight tooth and nail to make the best register user. For example, the EXAFAF tone, which I usually don't use, is interesting, which switches from A to A tone, I don't know how this is called in English. The auxiliary register also. I have a loop through every poly, and I have a loop through every edge of a poly, and I have the nigons. If I have 4 nigons, I have to loop 4 times. And so if you have 3 polys, triangle, you have to go edge from 0 to 1, 1, 2, but then you don't go to 3, you go to 0. You have to do the inversion. And I didn't want to do some kind of module or something, because then you might have quad, you might have Nigon. It has to go 0, 1, 1, 2, 2, 3, 3, blah, 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 and minus n up to 0. You know, something like that. And I do that. And I don't want, because I'm moving in the polygon and go to the next places, I don't want to restore something. So I am somewhere in the beginning, that 0, the 0 index and the value in the index, I'm storing it 0 value goes in 8, then I do EX, AF, and then at the end, when I reach this point, somehow I do some comparison somewhere with the number of points on, if next is over number something, then do EX, AF, to get restored 0. So I'm even using, because usually I don't use the AF tonos, AF dot, AF dash. I say the Greek name. I rarely use this EX. I usually use the EXX and other things. And I'm doing that so that in that loop that goes deep, goes for every polygon, for every edge of the polygon, and you have to read the number of. And if you read somewhere the last one, no last edge, yes last edge. I think in IX edge, I use the extended the low and high byte. I might be storing the number of polygons that I decrease, and if it reaches 0, it's finally the last edge. So you have to EX, say F. I will either read the next one and increase D somewhere, or switch for the last value to get the 0, not the 3. Not get the 3 here, but get no 3, get the 0 that I pre-stored in the beginning. So I'm doing things like that. It's much later I added the caches address. I'm doing some extra thing for, and this might be for the clipping. I definitely need to write some parts in a different way and even do it separate. Do you imagine? And I realized something, because we have a discussion that we say, maybe put the cube. Oh my god, this only gets 25. By the way, because of VSync, you don't see. You see either 25 or 50. Because of VSync and VBL, it logs in a way. So I have this thing, and I'm like, I'm even no, V. I'm even having the CPU, and I have to go very fast to start. You don't even get, you even overflow and it breaks. To even go at 50 FPS, and you think, okay, if this size can barely get 50 FPS, then this size, I'm gonna remove, this size would kill it, because if you think it was just the polygon area, or even the edge walking area, it is now the edge walking area also. It should go, this might be 16 times bigger, or 8 times bigger. It should go from 2 VBLs to 16 VBL. I should get not 10 VBL. This is 5 VBL. But it's not the case, because the bulk, the edge walking grows, bigger edges, more walking. So that kinda affects it, or the polygon filling, but it's also the side filling of the. And that kind of, I try to comment out things and get some wrong version, and they kind of affect. It's the whole thing. You think it would be the area of the polygon, I think. No, it's the whole clutter and the whole things you have to do that. Else, because it's the opposite. I see, okay, I'm getting something. If I go far, I'm gonna get 50 frames, but you don't get. So at least it's not very analogous to the area. Now that gets 50 frames, but it very fast gets 25. So there are very few things drawn for this to be so bad now. If I rotate this, if I have a slope, it gets a bit more. You see how it's variable. So it is a bit disappointing with simulating, but if you go close, it's not that, but it doesn't get 10 times faster. So the speed is not analogous to the area. Else, if that could barely get 50, this could be dying. This could be 60 times the area, and it's kinda okay. That's a nice object. Simple and nice. The spaceship. But the lines are. I haven't done the proper lines thing. The spacing is really for such polys. I mean, you still get a smooth cube. With not as smooth here. Yeah, boys, we do have clipping, but clipping only here. Here, no, it's gonna distort. It's gonna clamp the points, and here it's gonna break the erasure. This was always a complex. I never added it to the demo, this one. The star. I must have shown everything. See, so you have that thing. So I'm doing a lot of wild stuff with the rays. I'm doing. And this is one of the. It was separated function, but then okay, I might have unified parts. Not this one, the polygon. It was a function that some were calling another draw polys. That one later calls the fill edges, of course, after doing the edge walking. It finally goes and calls the fill edges. And it also clears the edge cache, but only the ones that we alter, not the whole thing. It doesn't unnecessarily fill the whole thing. And okay, there was a reason, I think, why I unify this. Maybe not because I was using the SP. Maybe I'm not using the SP. I decided at some point to use the stack pointer for tricks, so I couldn't call my function when I'm using the stack pointer. But I don't see this to be the case. Maybe I had some reason to. This could be two functions from top to bottom. Maybe I do this in a secondary function. So it's a huge monstrosity. It's even hard for me to understand. With comments, with comment out, some test because something went wrong sometimes. It's madness. So we talk about the polygon. Jump into a yeah, main is a date of the main. It could be written very, it's a mess. I'm talking about the caching of some of it, but I could be caching the whole process as long as I have some big area. Now the demo, I needed like I think 8K for the memory for the music. I have a lot of free area in this interactive code, even in 64K, and I had for the stars My God. And I wasted a lot of area on the demo screen. Glance, I talk, line rendering. Okay, line rendering. I didn't win. Okay, so line rendering. Uh, Again, for another time, I didn't went for Bresenham, and many people will be. I was thinking, what are you crazy? This is not optimized, especially for retro computers. Bresenham is the right. I read about Bresenham. I read how it's done. Maybe I did it once in some, but I always found it the thing I'm using. I found it to be more intuitive and easy to do. And Bresenham, I've read, I understand the amount that it does, but it has all of these weird terms that you have to prepare, and I will end up. I was planning to do it to write it first in C, because you might have to write different versions depending on the slope and the direction, which is also in my case too. And you have to fully understand this term because you might need, depending on the slope, they might change. I'm not, and it's not as intuitive. I don't find it as intuitive as the fixed point line rendering. Here's the thing. I'm gonna say something. The general knowledge in the general consensus, the common factoids in computer science, oh, Bresenham, the best line algorithm. And if you don't, they say, if you don't do Bresenham, you do DDA. They always use this term, digital differential, and I'm not sure even if you can press and I'm not sure where this term comes and if it's very generic. It's like you either do this or that. So if you say I didn't do Bresenham, I do DDA. What did you do? DDA, and it means various things. And the thing that they produce, and it's always Bresenham was the fast thing, and DDA was the slow, boring thing. But the thing they produce is an optimized thing. The example of DDA is something, of course, it's something that uses a lot of floats, and it's something that adds a differential on x and both x and y, and let alone this is in floating point, and calls put pixel and rounds the x and y, and the step might be depending on the slope. You might need a step that is a fractional of a pixel or something, because you might skip pixel. That's something that I never do. When I say I didn't use basic command, it doesn't mean that I use a slow thing like this. What I always use is something that with my insistence to use fixed point and fixed point steps, the first obvious thing I came was something that I realized much later someone else described, and it's a bit of interesting. Okay, I need to find this one because where did I hear this one? And I didn't know it existed. That's not that. Oh, there are many. I'm not gonna find. Okay, I was watching some DOS demo and some maybe it was the highest. No, okay, maybe demo. Let's see if I can find it. Pio Pio. Okay, that's a demo that was a 640 by 480. It's a bit minimalistic and it uses a line algorithm at some point. And it says, I was reading, and it says EFLA, EFLA, house marking, extremely fast line algorithm variation E, addition fixed point precalc, copyright this guy. And at some point I was like, what is this efficient line algorithm? And then I saw, oh, it's not Bresenham, but everybody says Bresenham is faster. And I was curious, so I went there. And actually, this has I diverted a lot. This has a very weird. Oh no! Why? EFLA line algorithm. Because his side is down. World's fastest algorithm, it's Wu and Bresenham. Okay, but there is a backstory. There was a guy who joined the alt computer graphics, and he was a lol cow. And he was like, I want to make a line algorithm. He was doing some bad line algorithm. I want to beat Bresenham or something. He was kind of cocky, and then he did something. People were fighting like, no, you didn't beat EFLA. And then he ended up in some result. And I discovered my own line algorithm. I'm famous, EFLA. Okay, and he established it, but there is still controversy. No, this guy is a lol cow. He didn't discover anything. And he would be posting stuff. There is a story, and I cannot find. Maybe. Ah, God, maybe it's not my algorithm. EFLA wins, but people were kinda pissed because. Okay, we found it. Because he was kind of cocky, like, I'm the new, I want to put my name in computer graphics, and what he did, I hosted, and it was what I did long time ago. I don't know if I was the first. Although I don't have in the demo. I think when I was working on LED blur, the thing is I don't have an effect in this demo, but I might have code. Maybe when I was working on LED blur, maybe I was looking at source code. I just didn't use it in the demo. I had also a line algo, which was even a de-aliased line, which is what I did in my demo with idealizing. It's exactly what I did there. Which is simply, anyway, I'm not gonna go over. What he did was just find the dy that exists. It's similar like I work in the edge. And then you say x for y's and y and yd. Yeah, that's not real. That's yeah, something like that. And the pixel is x if you are in a8 fixed point, for example. I think on PC I might have done it with 16 and 16, 16. And this is it. Suppose the division was fast, the rest was a very straightforward fixed point, add and shift. You know, and that's very now. And I was thinking, now I want to try Bresenham in the future. Bresenham has this weird thing where there are variations of Bresenham though. Where you have a loop, where you have an if then else, where you do some stuff and you do some other stuff. It's just addition. The 2 by thing is now maybe you store some of the, you can optimize and store some. It seems that it has a bit more branching in a way. It's not much. So I always find that if you are in this after you do this is very similar, very intuitive. I can write it with close eyes. Now this one, I have to go and copy the the code at the end, put it in some C++, see how it works, and see how I can port it. And it has a bit of some branching and the comparison, and it's adding one thing, it's adding also another thing. Now maybe some of these things you can calculate outside. It's not like you have to do everything. Okay, it's not much high. And I always thought that thing, assuming you pre-calculate the division somehow, which I didn't, that thing would be much easier to write it pretty fast. And but I don't know. Maybe in the future I have to write a very optimized Bresenham and compare. And I think I found some recent. Now Bresenham was something fast in the past. It might still be fast, but I found some benchmarks where people compared Bresenham, EFLA, lazy DDA. What does DDA means anyway? People talk about his algorithm. Oh, this is just DDA, and he says no, it's not DDA. What does DDA mean? It's a new thing. Now DDA still seems like, oh, but it's also add fractions. Yeah, but it adds both fractions. It doesn't loop pixel per pixel vertically and horizontally. It loops in a step which could be even smaller, even less than a pixel to not skip pixels, and it's all flows. It's quite it looks similar, but it's quite different. This is much easier. And I've heard that someone was benchmarking all of this in a modern PC, and because of maybe not so modern Pentium 3, and but then benchmarks are okay. Everybody's fine. Bresenham, oh, I won. EFLA is the best. This guy, I beat you. But really, EFLA is that. It's something I also done, something obvious. So I guess he's the first time person who wanted to establish it to feel like he discovered something. But it was something I did it on my own. Now he says copyright 2001. Okay, I must have done it at 2006, but I don't know. And it might be that I read somewhere modern CPUs, obviously, they're much faster, even if you do it in Flood. And there might be branch prediction issues and other stuff. So I don't know. So it's not always that. And maybe it wasn't the best choice. Although the traversal of the line can be can be faster, but the fact that I have to do a division could be slow. It could be better to use Bresenham for small lines, and I could make benchmarks and compare depending on the line length. And I have to write a very efficient Bresenham in Z8. I have to. It's just that every time I don't find Bresenham very intuitive. Even if I say some nice intuitive graph, it's not that I don't understand. I don't find with close ties. I cannot write it on my own. I have to go and copy paste the parameters and so on. And I know now mathematically how the parameters come, but and I'm just gonna use what works for me. And in this case, it's not the horrendous DDA floating point version that is presented. And the thing is, the draw line slow X or Y. The only thing I see, I haven't unrolled this one. I could have unrolled it, but okay, it's more complicated because I do the anti-aliasing, okay? It's not that, it's much more. But the original version could be something like, and I also have to find the pixel address, and the original version could be something like an add HL, DE and LDA, H, and also I have to get a line address from a table for the pixel position. Also, this whole thing is not optimized. because I have rewritten the line algorithm could be much faster. I have written in a way that in every pixel I I use some lookup table because of the video RAM of CPC to. It's like I inline the put pixel inside because I could have been in some ways and some more repeating code a bit more clever. Also, the anti-aliasing because you have fixed point. If x is at pixel 10 and then dx is 0.25 because it moves slowly. Now you are in 10.25. You can get the low byte in fixed point, and that will tell you if you will write pixel 1 near pixel 2 with color fraction. I'm not doing multiplies, I'm doing it I'm doing it with a table. Color tab or in some other way. So all I do is, and that's pixel 1, pixel 2, or if you are moving vertical, it's gonna be pixel 1, pixel 2. It depends on the slope. It depends if your line is going like this or if it's going like this. It depends on dy over dx. And if it goes like this, you have to move 1 pixel to the right and add dy. If it moves like this, you have many cases in reality. And I'm doing all these cases like drive slow. It might start from draw line. I might sort things. I might do some more things. I calculate dual weight x. I might swap so that I always draw certain direction. Draw line slope x or y. Depending on the slope, I might go in this or this. And I'm passing something in this region to know where to jump. This will go outside. No, no, there's a red here. And so depending on the slope, I might walk horizontally or vertically on the coordinates. And the slope will either be added to dx or dy. And the thing is, I have on HL things like video RAM line addresses, and I need to shift. I could have done something much more intelligent to not always have to calculate it. And why is this repeated? Because this is the second pixel in the anti-aliasing. I'm writing 1 pixel and one pixel to the right with different color based on the fraction. Somewhere the fraction goes. And see, and I'm increasing x, moving horizontally on x, on y, but I also have auto modification because there are cases where the line will go negatively, and I have to auto modify this depending on the slope. You see, it got somewhere I auto modify +1 somewhere else to account for the direction. Am I going like this or like this? Negative on x or positive? And I'm changing the opcode, the decrease dec c, dec whatever it was, to inc c, or oh my god, it's beautiful and ugly at the same time. And I theorize that I'm calculating horizontally the line address. I'm getting it from a table, depending on I have pre-stored the VRAM lines, and also for both, whether double buffer 1 or 2. And I'm gonna pass it this from outside, depending on the. And I'm gonna have to read if I'm on Y, and which Y coordinates I'm taking. Okay, I'm here, I'm getting the address here, and then horizontally add 4 pixels is 1 byte, so I do 2 shifts, and I'm doing some stuff, and I know how to. And the thing is, I move to the next byte, and I'm recalculating again. But in some cases, the next pixel byte might be at the same address. So I could have some logic to reuse it, but you don't know, because maybe the last pixel is in the previous byte and the next pixel in the next byte. But I could have thought some clever way where I detect it. Maybe some Duff's device unroll loop where I take this and I have it 4 times and it jump on the end and then it jump. And I could invert, and then you might do it vertically. You might write 1 pixel on a coordinate and the next pixel is below. If the slope is vertical, the idealizing might be different. So maybe I could even put some. Maybe this is good. So the way the idealizing works, and that's how it works normally. And I found that this is called the who lines algorithm. Who idealized line. So that goes always. I read what he's doing, and he also has 2 cases. He's inserting nearby pixel depending on the fractional. And even the original pixel is not full. And it has case depending on the step, if it's going too vertical or too horizontal, it might insert. He does it y minus 1, y. Yeah, I'm not sure if, yeah, maybe I'm looking at some other code. So there is a point, there are various. It really does something similar. And so I also figured it out when I was doing a fixed point idealizing. The next idea came, whoa, if I'm doing fixed point, I can actually, and I could look at idealizing in other demos or games or whatever. I would take a screen, I would zoom in, and I would notice that this is what happens. That as it gradually moves, so I would not see the visual part and realize as it gradually goes from here to here, it's really moving. Yeah, the real line is moving from here to, so it's passing. So the fraction part is increasing slowly in less than a pixel. So if you get the fractional part, you can kind of know the smaller or bigger it is, and you may need to do a sub also from. And if you go vertical, you have to render the next pixel. At this corner and the next on horizontal. If you go horizontally, you have to go vertically really. You see here it's very steep and it goes vertically. You have to render either the current pixel and the next one to the right, or the current pixel and the next one to the bottom. And just using the fractional, and I could make a version with, I could unroll some code vertical too. I could unroll this code 8 times because every 8 lines the video RAM repeats, and have some auto-modified jump inside that starts forward and then goes in some Duff's device thing and then escapes. It's gonna be, I would have to get both this and this. Expand it, unroll it maybe 4 times this and 8 times this, so that I made it, I write it for the CPC video. I'm in a much more optimized way that I don't need to calculate the line address every time. Here, for example, if you jump if this is repeated 8 times, you know that inside a character add 2048 and you go to the next bit, and then you have to go back and add 80 bytes or 64, however your width is. So I saw that much later. After I was looking and say, oh my god, I could write some much more optimized, because I'm calculating. This is a put pixel thing. I scrubbed it in line and I lied it for the 2 pixels, and so there are so many things you can do. It's amazing. So you've seen the demo, you've seen that, okay, it's kinda, sometimes it's slow, sometimes it's pretty good. Relatively to what others have done with real-time polygons on the CPC, it's impressive enough. But imagine that there is room for potential. The great thing is that there is room for potential. There's absolutely room for potential. Oh my. And now I'm going to, this is the interactive thing. It's pretty cool, huh? See that? I lost it. Okay, I have a button. No, not this. This. I have a button that resets. See now, I'm getting 50. If I rotate so that there are more edges to walk, it goes to 25. If I put it here, and the polygon area could be roughly the same, but if you rotate this side, even if it's small, it goes to 25, and here you could even go. Okay. See how variable is depending on the siding. So if there are more edges on the screen, there is a lot of waste. Rather than the fill area will take some too, but there is potential for improvement. And even that, this torus is impressive. For the number, even if it doesn't do, it does 8 frames for a number of polygons on CPC. And again, if you pause it here, maybe rotate, it might do better. Yeah, now that's more area to big. Oh, some polygons disappear. Yeah, it's very close to Z and something. Far away, it does quite better. And that beast, that's a beast. Oh, I need to enable sorting for this one. I never included that in the demo, because I get the simpler one. So did I go? Okay, no, that's the scripts from the interactive. So here I have the interactive. This is the new board, and this one is the original demo that I have more stuff. I have the music, I have FX stars. FX stars are more simple, and I end up creating a division table for the projection to improve, because I'm always gonna, in the first part, I'm always gonna show the stars, and I don't want the stars to add on the total slowness. 64 stars. I need some division. However, with the stars, if you have x divided by z, now z naturally goes from 0 to 255. I never divide by 0, okay. And they move smoothly, so z moves smoothly on x. If the stars were, maybe they're 127 to 128, 227, whatever. And maybe I can store big loot 127 255, so that I do abs x big loot sort of, and then if it not that, but store, okay, store the, I thought about that, store the sign and restore, so that I can, else I would have to do a 255, and that's and this is 64K. I don't have that memory, man, not even that. So I think the thing I did was like, you know what, truncate the star codes for x and y, only allowed values 0, 16, 32, 48, and so on. 16 values. Loot. And maybe I could go, okay, I don't want to do the sign thing, and put 32. And that's like 8K. And indeed, okay, this is from the demo. My stars are sitting, my stars are 6,000 and goes till I wasted 8K or something. Now, when I decided at some point to go 0.3264, so I made the, in this very grid, you started seeing the grid. So I could do something with much less value to gain some more. So this was the final size to still have stars that they are only on these positions, but you can see. Now the negative is if I wanted to offset the stars horizontally, because that was initially planned to make it move left and right, they would jump through values because of this. Now before, just stars over 20,000 knobs, but close. After 6, 7 maybe. And maybe I'm not very optimized still. But now I can have machine. I also delete the stars. I have to erase the points. I have to store the points to erase in the next frame. I do all that stuff. So I clear the previous stars, I draw the new stars, and then I start rendering my object. At least this whole thing wastes 6, 7, less than half a VBL. So that was kinda better. And object would take 2, 3, 4, 5, 6 VBLs anyway. I didn't want to really kill it more, so I went with that loot. But see, unless there are more clever ways to do the star projection without. So that was with the stars. And I would move the stars, but I would only move the Z coordinate. I would get ticks different. Everything is scripted with ticks. Accelerate starts to value and decelerate starts to value. I have special functions to do the stars moving forward, then going backward, then stopping, and so on. And the big thing from the actual demo is the one thing is the 3D function, of course, helper functions that I needed, and then the script is big. The script is big. The script is big and ugly. Ah, not so big. I thought it was more big. And it's bloated code. It doesn't matter much in the performance because it's bloated. It's bloated on size. I can always improve things. I did some improvement after, and I found some functions I was using that I didn't need to. 3D functions, okay. The script goes okay. Read some text differences. I'm starting some multiply text difference because I happen to be using them frequently. Previously, I would load the the elapsed time text since the previous frame, which I get from the interrupts. And there are 300 hertz per second. So there are 6 per frame. And maybe your frame took few VBLs or 27 ticks. So it was good enough for scripting. Because things were taking a lot of, and I had enough ticks to have a good tick timer. And sometimes I got the ticks and I want to use them for the rotations of the object for the based on the timer. And I wanted to see add HL, add HL, add HL, add HL, add HL because I wanted some of the ticks weren't big enough. And I had places in the code where I was doing add HL, add HL, add HL, add HL, and then I saw okay, there are like 11 places where I really want the ticks diff 16 because I use it frequently. It was a nice time. So why not? I did that after the party version. I'm doing this for the final to gain memory as much as I can. Why not remove all that stuff and a bit of speed maybe? But those are running once per frame, so they are minimal for speed, but wasteful for me. Let's get the ticks diff on for each frame, and let's add the multiplied value so that if I need that, I can just read it back. Call min max area CLS, and then I have a part number. Part 1, script part 1, part 2. Part 1 is the stars part before the line rendering, then the line rendering. The line rendering part and the final 3D objects and lens are all in part 2 at the end. And part 1 was the bigger, and it's kinda okay. Get me the seconds, and depending on the time, go to subpart 0, 1, and so on. Face screen, Excel starts to script part logo, blah blah blah. Red, script spaces, 2, blah blah. Now, I was thinking that I should have made some kind of scripting engine where I would say time function pointer or rather something that I'm not gonna hard code it like this, but that's something to do in the future. But I didn't have time to do, so I manually did. And there are all the script part 2, the line render, script render object. And it's all a mess, like script part logo, script part if this time and that time and not that time and not see I have commented out this because now I'm getting text diff and it's all over here. Logo star no script, it's the typical demo script, not typical that list of the line objects, and you have all this kind of function that script various things. Now I'm repeating that time. I wanted to shift some values from the sign data for the movement. I have commented out a lot of stuff. Script object, script spaceship 1, 2, 3. So it was very manual labor. Script render laser go, the laser thing. I do some ugly flash things. Render UFO 1 and there's UFO 2. And the UFO 2 and all kinds of flags. Now for some reason I moved the flags here because I had this early code that okay 0D00 I don't have random yeah 0E sign data 256 block, and I started this for the plot bytes balance, and there was a gap because my demo would start at 1000 then. And to gain more space, I say as gap as I have, go a lot of these are I move things away from where they should, to be honest. Move this, and when I compile this, I'll check if this plot by data end didn't go to 1000. And when I stop, I say, okay, I'm not putting any more stuff here. So there are a lot of flags and variables that are used in the script all the way. Is object in now? This object in now once logo start trip is in need. Road test still has swap glance object in blah 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 blah. It's yeah. It's a bit insane, but okay. But initially those things would be near the function, which was more convenient to know what that is. It's only after the party version, when I started trying to save memory, that I did things like this. And one final thing for the lines. You know that in the demo, I'm doing this. I'm doing this very nifty trick, which I thought later. I did the line rendering first, and then I thought, whoa, what if I do this dotted lines, interrupted lines for transformation? It's amazing. Not only the anti-aliasing line is pretty, in some sense, in the rendering sense, it's pretty impressive for the CPC, but also this kind of warping thing. So, and to do that, it was just a hack on top of a hack, but then I had to optimize something. It was a hack. I only have it on the demo. I removed it from this, the interactive, because it's a bit ugly and unnecessary for an interactive thing. And I ended up duplicating code. I have the draw line final that does the full draw, as it should, because the idea was to just have a διακεκομένη. So intermittent, maybe when you have lines that are cut together, you say διακεκομένες γραμμές. Dotted line, dashed line, broken line. So I call this thing, even though I usually use English labels, I call this diakek line, draw line final diakek. This is the diakek. So if I script for the diakek to happen, I just have some value that goes from 0 to 16 that I gradually change, and during the line loop, this is the pixel per pixel line loop. During the pixel per pixel line, I either choose to continue or skip, but I advance the coordinate. I skip here so that the ink see to go to the next coordinate happens, and the same here. So in half of the pixel row, however near one, I skip. So I draw the pixel, not draw, but continue. Guys, it's that simple. But later I realized even if there is a bulk of stuff and this is small, it still would still cycle. It's still costly. So when the object code complete and there was no reason for the hack, I wanted to hack it in other ways, but it would be ugly. I ended up to have the full one that I don't even do that. I don't do the extra. And I don't know if this is on the party version or the final version. If the party version is still always running the dotted line, even if it's a full line. Even though when the full line appears, it's... and the difference is not much, but it was kinda wasted to always. But yeah, that was the trick there. And finally, I think we can finish, and I'm gonna show you some older previews. So now, I found an old DSK. I was looking at my older code, and I found an old DSK. I have a lot of previews when I started, and there is even the big sized object. And let's see. The very, very early things. I might just remove the. I'm hearing the very, very early. I might have done this 3 months ago. At this point, no, at this point, 4 months ago. The 64 rotated point. I think this runs in 2 VBLs. And I believe though, and it's not very optimal. It uses the technique with the XYZ grid, or maybe it's working on the grid and adds the values, but there are not enough registers. And I was doing some push back and forth even in that one. And it's still nice. But I believe seeing the Commodore demos and that, I believe there are other ways to do 200 3D dots. However, I want to say the dots on Nether, they don't have perspective. That's the other thing. Here I do the perspective divisions. And maybe that's another reason why I get into 2 VBLs instead of 1. Well, what I liked was that despite being 8-bit and 16-bit, the rotations are pretty smooth compared. Sometimes I see some 8-bit demos where people try to do 3D, and the dots are like, they are jerky. The dots are jerky. Oh yeah, I was surprised when I managed to do my first and try to find the right dimension and the right precision and so on, without going to some 32-bit numbers that, wow. So that's, okay, that's more this. Okay. Oh, that might be much later. I thought. That okay. That's the stars. Oh, that's an early one where I swapped the objects with the stars. I don't know which version of the star. You maybe you see the big object here. It's gonna go very slow. You're gonna see the biggest object that I could. It's kind of choppy. And maybe that's an early version. Oh, the infamous square ring. Maybe I saw that here. Maybe not. And also that object. From a distance. Oh boy, yeah. The 8 cubes. The 8 sorted cubes. It's one big object. I think it's 64 polygons. Oh, and the glens. A smaller version of the glens. And that previous object is a bit of a killer. And I think the cube is smooth here. Multi 3D. Okay, that was the first test where I wanted to have more than one object. The move one is further than the other. And they have different areas, so I erase dirty rectangles, erase the thing so I wanted to try that too. Not unified arrays and not full screen arrays. The movement was junky because I think I was getting some war sticks. Oh, that's an okay. When I started developing the polygons, you see that it's blocky. This is because I only have the crude bytes version. I didn't start working. I started with the crude bytes, like skip the edge polygons where you might have to do a mask and render 3, 2, or 1 pixels. Rather, render only. So when I got this block thing, I was like sad, wow, because it was a start, and there were a few bugs I see. That's the star object, but with lower. It becomes convex. But it's also the base for the glens, that object. And even if I was doing the polygon thing, it was like this is where I finally got it. That cube looks smoother, early version. Maybe I don't do some extra clipping and other stuff. Or maybe the movement is differently timed. Yeah, you might see sometimes on the edges some pixels. These are bugs that I fix, some pixel errors. Oh, the glens, of course. Cool. That could be 1 month or 2 months ago. Now, from now that there is a distance from the demo party, from the combo, definitely. I have things early, and the scripting happened much later. Maybe I did the scripting in 2 weeks. Okay, we missed the demo party, so maybe I did it in 2, 3, and 4 weeks. Maybe in 3 weeks or 4 almost. Now this is where I will be sorted. And now I'm also displaying the interrupt barriers. Stable, but sometimes you see they are not so stable because of the push pop things I was doing. And I didn't talk about these things, but okay, I think I'm not gonna finish them. That's the object that needed. This object needed sorted. Only this object. We might see the big object again. So I never included this one. I included the more complex torus, which I don't know if I have here. Oh yeah, in a bigger side. Interrupt jumping, it goes pretty slow. Maybe it's 4 frames per second or something. It's the most complex thing I run. It's not very complex, but it's complex for CPC. It's not eight objects. It's one object that is defined as these 8 cubes. They are not 8 separate. I could have done it like that, but... And of course the glance. It's pretty smooth here. Alright. And I have some stars 3D. We already have seen stars, so... Early version of the stars. No fade color of the stars. Now, does it have... There is a version that has sounds. Let me see. Fast forward. Okay, no. Just that. The cube and the stars. Now this is 17 because I was testing the music playing while things are running. It's using the music from Fractoid for a test. The torus flying through the stars. My fear was because I was doing crazy things with the stack pointer and places. I was abusing the stack. I set up the interrupt. I thought things would collapse. There were times that things will collapse. In the beginning it was collapsing just with the interrupt, so I have to go and change a lot of things. what if the CPC was on turbo mode? Oh, smooth. Imagine if the CPC was like that. That would be amazing. Smooth complex torus. Ah, the wireframe. Okay, that's the classic line rendering without anti-aliasing. It is smoother. And you see this object, it doesn't do the back face thing where I hide the back. It just renders everything. Which means it's rendering more lines than is. But it's much lighter because it doesn't do the anti-aliasing thing with the double pixels. I remember this to be slower, but wow. Why anti-aliased? That was the anti-aliasing. That feels smoother, but maybe it's my timing. I don't think I broke the demo code. There is a bit jumpiness only with the because I move it slowly. And now see this. There are polygons that are partially hidden. I cannot do the with non-convex objects. There are things that disappear. They disappear correctly because the polygons are hidden, but they are not really hidden. Oh, and I have okay. These are objects that I never defined the full lines. I defined the quad for some reason. Oh yeah. All lines, no. A very complex line drawing thing. I think it's the glance. This is the glance or something, but with lines. They are so beautiful. I was very excited when I made the anti-alias lines, especially on a CPC. And imagine they can be optimized much more. You can make them. Could have written much better. Now I see. Wire good. Okay, that's the same wireframe, but with the back face scaling, with only show the front faces. Pretty smooth. Ah, the UFO, but smaller height. I remember a Cascada demo where they were showing a UFO with yellow and blue colors and said, "What is this? A Swedish UFO?" And then they saw red and white, and that's a Norwegian UFO. I'm excited because, okay, I'm doing 3D in a very limited platform, 8-bit, and precision is still good enough for such low fixed point numbers. Back in the time, I had issues with high fixed point numbers. Even with 16-bit and 32-bit, I would get into overflow, but I wasn't handling things well. Maybe my vertex coordinate, they weren't 1, 2, 3, 4. They were bigger numbers, and I didn't handle well. FFF is nothing. It's just a generator. I don't know what it is. I don't remember. It was a generator for some data, and that's it. Yeah, I guess no, don't save. I don't know what it is. And that's it, guys. It's that amazing. And I'm planning to continue with this interactive. I could use the engine for things. I could try different ideas and different optimization, but I might port it to mode 0 at some point so that even rewrite some part. I can have more colors to do proper flat shading. Even though I was thinking in mode 1, I could have done some dithered scan line feeling for the point to add some kind of more shades with the 4 colors and do some kind of flat shading, you know, with normals. I can do that too in the future. I know how to handle normals to avoid a lot of calculations, or at least some of them. There is a way that you don't have to rotate any normal. You have to rotate 0 normal. No multiplication, not even my trick for this. You have to rotate the light on the opposite direction, the directional light counter, and it's like you rotated the several normals. But then you have to do the dot product, and that involves multiplication, so I don't know. Unless there is some... but it's a bit of an extra. So I want to do flat shading, and my dream is to do gross shading, which mode 0 would be perfect for. A mode 0 would be perfect to write a bit more clear and easier scanline renderer. Because it's only 2 bytes per pixel, not 4, and there are fewer cases and easier masks. Gross shading, and maybe I'll attempt texture mapping. Maybe just a texture cube with UV coordinates. So there are a few more steps to, and I'll see. Maybe I have some ideas of how I could use the engine for some simple games or even more involved 3D games. I'll see, but maybe I should go slowly because these are too much. And even that, my God, it was three full months of entirely working on this. Amazing. See you in next video. Bye.